Okay, hello Cloud Gurus and welcome to this section of the course. This section of the course is on security and compliance, and this lecture is on compliance frameworks. So compliance we're going to cover off in the very first lecture. It is pretty much the driest of, of topics, so we'll try and cover it quickly, but you do need to know it at a high level for your Certified SysOps Administrator exam. Then move on to security. We'll look at things like DDoS mitigation, we'll look at things like SSM, we'll look at things like the AWS Marketplace, where we're doing penetration testing and what tools are available there. We'll look at identity access management, we'll look at roles, we'll look at security token services, a whole bunch of other security products, and it is lots of fun. I actually enjoy security the most out of cloud. And if you do enjoy this section of the course, make sure you check out our security certified security specialty. In order to do this certified security specialty, you need at least one AWS associate cert under your belt, and then you can go on and do the certified security specialty exam. The certified security specialty course is available on acloud.guru. It's really good. It goes in depth into security for about 12 to 14 hours, and by the end of it you'll be able to clear your certified security specialty exam. You also learn a lot and you'll have an awful lot of fun. And the certified security specialty exam, by the way, the certification itself is in huge demand with employers right now, because who doesn't want to be secure on the AWS cloud? Who doesn't want certified security experts on AWS? So let's start with compliance. Compliance is a little dry, so we'll go through it quite quickly. But the three compliance frameworks you should really be aware of, both in the real world and for the certified SysOps Administrator Associate exam, is the PCI DSS or PCI standards, ISO, and HIPAA. And HIPAA is actually only for American students. HIPAA is basically, we'll go through it, but it covers how organizations handle healthcare information inside the United States, whereas PCI and ISO are international standards. So you will need to know PCI and ISO no matter where you are in the world. And I would check out the AWS compliance website. So it's just aws.amazon.com/compliance. So let's start with ISO 27001 specifically. So ISO 27001 is a certification an organization can get. They have to go through a sort of audit process in order to do it. And it specifies the requirements for establishing, implementing, operating, monitoring, reviewing, maintaining, and improving a documented information security management system within the context of the organization's overall business risks. So basically you need to have a documented information security management system, and you have to have a series of ways of not just, well, first you have to establish it, then you have to actually go out and implement it, and then you have to operate it and monitor it and review it and make sure that it's constantly being maintained and improved. And it can actually be, as you can imagine with AWS, as the number of services grow and as your organization adopts more and more services, you need to implement these services into your information security management system. So ISO 27001 does that, and basically attests to other organizations that you have an information security management system in place within your business. Obviously, AWS is ISO 27001 compliant as an organization, and if you are a managed service provider, hopefully you're ISO 27001. I remembered when I worked as a solutions architect, the very first thing we always got on RFPs was, is your organization ISO 27001? Yes or no? If you click no, please do not bid on this on this RFP. So hopefully your organization is. Just be aware of what ISO 27001 is at a high level. Moving on to FedRAMP, this is the Federal Risk and Authorization Management Program, or FedRAMP. It's a government-wide program that provides standardized approach to security assessment, authorization, and continuous monitoring for cloud products and services. So again, this is a US government program, and it's relative to US companies, doesn't apply necessarily outside of the US market. Although, of course, if you're dealing with US customers, they might insist that you FedRAMP approved. HIPAA is a huge one inside the US. This is the Federal Healthcare Insurance Portability and Accounting Act of 1996, And the primary goal of the law is to make it easier for people to keep health insurance and to protect the confidentiality and security of healthcare information and help the healthcare industry control administrative costs. Now with HIPAA, you'll see if you watch AWS this week, basically you can't just say AWS is HIPAA compliant, because there are some services within AWS that aren't HIPAA compliant yet. So basically whenever AWS release a new service, they then, once it's gone into general availability, or certainly when it's in preview mode, they'll start going through the HIPAA approval process and hopefully get that HIPAA service service compliant for HIPAA. So you do need to check out AWS's website to see if individual services are HIPAA compliant. Lambda is now HIPAA compliant, but there could be some services right now that are relatively new that might not be HIPAA compliant. So do check out AWS's website to see if things are HIPAA compliant. But again, you just need to understand that HIPAA applies for the storage and maintenance of healthcare information on the AWS cloud within the United States. We also have the NIST, so the National Institute for Standards and Technology. Basically, this is a framework for improving critical infrastructure in terms of cybersecurity. Again, this is US standard. It's a set of industry standards and best practices to help organizations manage cybersecurity risks, and you can visit the framework by going to nist.gov/cyber framework. This one, PCI, Payments Card Industry Data, or PCI DSS, so Payments Card Industry Data Security Standard, is basically the most important standard you ever have when working with, certainly working in retail, working with online stores, or any kind of online market that takes credit card payments. So it's a widely accepted set of policies and procedures intended to optimize the security of credit, debit, and cash card transactions and to protect card holders against misuse of their personal information. So if you want to work in security, you need to know PCI DSS backwards. And I literally, when I was interviewing for security roles before I started A Cloud Guru, I learnt the 12 PCI DSS steps from memory, and that really kills it in a job interview because not many people do know that. And we will go through that right now. So PCI DSS, we're up version 3.2. I would say, by the way, so Amazon, their platform is PCI DSS compliant, right? So it's certified to a PCI DSS component. That doesn't mean that you can just go out and build something on the AWS platform and take credit card information and say, yep, well, Amazon's PCI DSS compliant, so I must be PCI DSS compliant as well. It doesn't work like that. So Amazon, the actual infrastructure, is PCI DSS compliant, but then the apps that you build on top of the infrastructure, that needs to be PCI DSS compliant as well. So you need what's called like a gap audit, is what it's sometimes referred to, or a delta. And so you need a PCI DSS consultant to come in, do this gap analysis, look at your actual application, and then submit whether or not you're going to be PCI DSS compliant. So bear that in mind. Let's go through the 12 requirements. So requirement number 1 is to install and maintain a firewall configuration to protect cardholder data. So obviously through security groups and network access control lists, Amazon do that quite well. But then if you have a security group and you just open up all the ports in the world, that's not going to be that's not going to be PCI DSS compliant, is it? So this is what I mean by Amazon get tested to a certain level, but then it's up to you as an end organization to continue on with this. Requirement 2, do not use vendor-supplied defaults for system passwords and other security parameters. So don't ever use username, admin, password. So requirement 3, protect and store card holder data. So this would be things like if you are storing card holder information at rest or inside a database, you want to make sure that database is encrypted at rest. Requirement 4, encrypt transmission of cardholder data across open public networks. So always use SSL when encrypting or when transmitting cardholder data. Requirement 5, protect all systems against malware and regularly update antivirus software or programs. Requirement 6, develop and maintain secure systems and applications. Requirement 7, restrict access to cardholder data by business need to know. So chances are your system administrators or your let's say your sysadmins, they don't need to know or be able to see cardholder data, right? Really, it should only be the people processing the payments and the people taking the cardholder information who will be able to see that. Requirement 8, identify and authenticate access to system components. So again, use things like identity access management, maybe multi-factor authentication, etc. Requirement 9, restrict physical access to cardholder data. So it might be that you're an old school business and you're, I don't know, like those old machines that used to take copies of the credit cards that would sort of like take an ink copy. And maybe you store those pieces of paper in your business, or maybe you, I don't know, print out people's credit cards for whatever reason. You need to restrict physical access to that cardholder data. It could even be that you just store it all on a database server inside your on-prem environment. You need to make sure that people can't just go and plug into that database server and use the username and password, admin password, to get in and get access to that cardholder data. Requirement 10, track and monitor all access to network resources and cardholder data. So you could use something like CloudWatch, or you could use AWS Config, or you could use something like CloudTrail, or a combination of all three, to make sure that you're monitoring all access to the network resources. Maybe someone's provisioning new resources, maybe someone's going in and changing settings in there, so that'll be a combination of CloudTrail and AWS Config. You could use CloudWatch to actually monitor people, going in through an Elastic Load Balancer to some back-end system as well. So requirement 10 is track and monitor all access to network resources and cardholder data. Requirement 11, regularly test security systems and processes. So this could be things like penetration testing, for example. And then requirement 12, maintain a policy that addresses information security for all personnel. So that is PCI DSS 3.2, the 12 requirements in a nutshell. If you can try and memorize those, you honestly don't need to know them for your SysOps Administrator Associate exam, but it's a fantastic way to blitz an interview. If you can go in there and just say, yeah, I know PCI DSS, here's the 12 requirements, and just spit them out, it's a great way of standing out from the crowd. Now, you may be wondering, how am I going to remember 12 different things for PCI DSS going into an interview? I highly recommend either of these two books, especially the book by Tony Buzan. He's the creator of Mind Maps. So the memory book will basically teach you how to remember things. So I've used this to memorize the PCI DSS standards. I've used these to memorize the Amazon leadership principles. So when I went in for my interview with Amazon, I was able to name all 14 leadership principles just off the bat. You can use this book to memorize. I used to know all 45 presidents of the United States in order. I haven't done that in a while. So it's one of those skills that if you don't practice it, it doesn't necessarily stay with you, but it is a great way of standing out from the crowd. And Darren Brown's Tricks of the Mind is actually really entertaining, and it explores some of the same concepts of memory, but it's also fascinating. It's about psychology as well. So I highly recommend these two books. If you do want to stand out during a job interview and know all your PCI DSS requirements, as well as perhaps the 14 Amazon leadership principles, check out those books. It is actually easier to memorize things than you think. It's all about association. So moving on to some other frameworks, we've got SAS 70. This is a statement on auditing standards. We've got SOC 1, so the Service Organizations Control, and this is an accounting standard. We've got FISMA, which is part of the Federal Information Security Modernization Act, so this is part of the US government as well. And if you're SAS 70 certified, you'll get this logo that's down below as well. And then we do have some other frameworks. This slide is actually from the security specialty. So FIPS 140-2 is the US government computer standard that's used to approve cryptographic modules, and it's rated from level 1 to level 4, with level 4 being the highest level of security. Key Management Service doesn't meet level 3. If you want to meet level 3 on a FIPS 140-2, you're going to need Cloud HSM. Again, this is from the Certified Security Specialty. You do need to know that in the Certified Security Specialty. You don't need to know that for the Certified SysOps Administrator Associate, but it's a good thing to know anyway. So in the Certified Security Specialty, you'll be asked to meet a particular level of FIPS, and then I'll ask you which AWS service you should use to do that. Cloud HSM is by far the most secure. So that is really it for compliance, guys. It's not very exciting. Amazon are compliant to a whole bunch of different standards. You can go check it out on aws.amazon.com/compliance. Seriously, if there's one thing you do take away from this lecture, get one of those two books. Like I said, I highly recommend both of them. And you can do all kinds of parlor tricks, in front of your friends and family. You can memorize an entire deck of cards. It doesn't take all that long. All it takes is practice. So if you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at DDoS, so distributed denial of service attacks. So you will need to know quite a bit of this going into your Certified SysOps Administrator Associate exam. I would highly recommend reading this white paper. The link is going to be in the resources section, but this is a AWS DDoS white paper. It's about how to use AWS to protect against DDoS, all the various services that you can use. I'm actually really fond of this white paper as it was my first ever job as an AWS solutions architect. This white paper had just come out, and basically my first job was to read this white paper and then evaluate a particular customer in the UK's environment and see how well it complied to this white paper and any sort of suggestions I could make. And so I ended up writing like a 30 or 40 page report on improvements they could make to their environment. And yeah, that was my first job as an AWS solutions architect. So do check that white paper out. Let's just start with what a DDoS attack is. So a DDoS attack is a distributed denial of service attack. Basically, it's an attack that attempts to make your website or application unavailable to your end users. This can be achieved by multiple mechanisms. So it could be achieved by things like a large packet floods or using a combination of reflection and amplification techniques. Also by using large botnets. If you ever use Tor, you can go on to the deep web and you can find places, used to be like the Silk Road, they've all changed their names now, but there are marketplaces where you can just go in and buy or rent access to botnets, and you can do your own DDoS attacks, and you pay for them using Bitcoin or using Ether, etc. And it is literally that easy. Like anyone with a credit card can go out, install the Tor browser, find marketplaces to rent access to botnets, and you can just launch your own DDoS attacks against websites. So DDoS is actually something to worry about. It is something that almost anyone can do. There are other methodologies that you can actually use, things like Google and Facebook's servers to create your own sort of customized style of DDoS attack. I'm not going to tell you how to do that. It is interesting stuff. Like I said, I love the security aspect of cloud. The stuff that you can do is quite fascinating. But yeah, it is definitely a huge problem, in the commercial world, and so you need to know how to protect against it. Let's look at some of these sort of common attacks. So an amplification or reflection attack can include many things such as NTP, SSDP, DNS, ChargeN, SNMP attacks, etc. And it's basically where an attacker may send a third-party server, so let's say an NTP server, a request using a spoofed IP address. So NTP is just Network Time Protocol, and you're basically sending a request to that NTP server, and it's a spoofed request. And basically what you're spoofing is your originating IP address. So you're pretending to be someone else. So you're sending a request and you're sending it with a false IP address. So that server then responds to that request with a greater payload than the initial request. And usually it's within the region of 28 to 54 times larger than the request. And it's actually responding to the spoofed IP address. It's not responding to your server. It's responding to the IP address that you're spoofing. And this means that the attacker sends a packet with a spoofed IP address of 64 bytes, let's say, and the NTP server could respond with up to 3,456 bytes of traffic. And attackers can coordinate this and use multiple NTP servers a second to send legitimate NTP traffic to the target. So let's see how this works. So we've got the hacker's IP, so it's 190.1.2.3. The victim's IP is 245.1.2.3. And then you've got your NTP server in the middle. And what the hacker does is they spoof the victim's IP address. So they're saying, okay, my spoofed address is 245.1.2.3 and my destination address is the NTP server. So you send down 64 bytes of traffic to that NTP server. It then responds with 3,456 bytes. And of course you can do this to multiple NTP servers at once, and you basically overwhelm the victim's IP address. We also then have things like layer 7 attacks. So this is where you've got an attacker, you've got the web server, and you just send a whole flood of GET requests. So you're just flooding the web server with GET requests, and essentially the web server just cannot process all these requests, and it stops accepting connections and it falls over. We then have another one called a slow loris attack. Here is a picture of a loris or a slow loris. They look very, very cute. But a slow loris attack, basically slow lorises move very, very slowly in real life. That's why they're called slow lorises. And a slow loris attack is a very similar type of, well, it's very similar to the name slow loris. So what happens is the attacker sends connection requests, but he does it in such a way to keep as many connections to the target web server open and to hold them open for as long as possible. And basically accomplishes this by opening connections to the target web server, and then you're just sending partial requests. So periodically you're sending HTTP requests and HTTP headers, and you're adding to, but you never complete the request, and you're basically just trying to keep this open for as long as possible. And your affected web server will keep these connections open, filling the maximum concurrent connection pool, and eventually denying the additional connection attempts from legitimate clients. So that's how a slow loris works. And yeah, essentially people can't access the website either because you've got a flood of GET requests or a slow loris attack. So how can we mitigate against DDoS? Well, we should minimize the attack surface area. We should also be ready to scale to absorb the attack. So by minimizing the attack surface area, we would use things like application load balancers with web application firewalls, rather than just having a whole bunch, let's say, of web servers that is using DNS round robin. Be ready to scale to absorb the attack. We would use auto scaling groups. So if we, if our web servers are starting to max out, we can add more and more web servers. We can safeguard expose resources, and we basically need to learn normal behavior. So what does our site look like normally? That way, when we know what it looks like normally, we can figure out abnormal behavior and then protect against it. And then of course, once we know what abnormal behavior or what normal behavior looks like and what abnormal behavior looks like, we can create a plan for attacks. So that really moves us on to AWS Shield, and this is what's going to come up in the Certified SysOps Administrator Associate exam. So what is Shield? Well, it's a free service that protects all AWS customers on Elastic Load Balancing, Amazon CloudFront, and Route 53. It protects against SYN UDP floods, reflection attacks, and other layer 3 and layer 4 attacks. And so AWS Shield comes for free with all AWS accounts. You then have Advanced, so AWS Shield Advanced, and this provides enhanced protection for your applications running on Elastic Load Balancers, CloudFront, and Route 53 against much larger and more sophisticated attacks. It's $3,000 a month. But if you're a large enterprise, seriously, it's worth the money because you get a dedicated team to you. If you do suffer from a DDoS attack, you won't actually incur the extra costs that attack is done. So if you have to provision a whole bunch of more EC2 instances behind an auto-scaling group, the cost of those instances are free if you're using Shield. And it provides a always-on flow-based monitoring of network traffic and active application monitoring to provide near-time notifications of DDoS attacks. So you can get near real-time notifications that you're being DDoSed. Like I said before, you get a DDoS response team, DDRT. They're 24/7, and they're going to help you manage and mitigate application layer DDoS attacks, so things like GET request floods or slow loris attacks, or etc. And like I said before, it protects your AWS bill against the higher fees due to Elastic Load Balancing, CloudFront, and Route 53 usage spikes during a DDoS attack. So AWS Shield Advanced is $3,000 a month, whereas AWS Shield comes for free. Going into the exam, just remember what Shield protects against. It protects against the three main things, so CloudFront, Route 53, and Elastic Load Balancers. So on to my exam tips, definitely worth a few points in the exam. Go ahead and read the white paper. To be honest, the white paper you don't necessarily need to know to read before doing the Certified SysOps Administrator. You definitely need to know it before doing the Certified Security Specialty. So do check that out. And just remember the technologies that you can help use to mitigate a DDoS attack. So you can use CloudFront, Route 53, and Elastic Load Balancers. All those three services is what Shield helps to protect. You can also use WAFs, and you can also use auto-scaling for both WAFs and web servers. And you can use CloudWatch to alert you for when you're being DDoS. So that is it for this lecture, guys. Hopefully you've learnt an awful lot about DDoS. We're not going to have a lab on DDoSing. I'm not going to show you how to DDoS websites because because I'm pretty sure that's against the law. But I'm sure there are YouTube videos out there that can show you how to do it if you want to go down the rabbit hole. So that is it. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. So in this lecture we're going to look at the AWS Marketplace and we're going to look at security products on the Marketplace. AWS Marketplace allows you to provision virtual machines that have already been created for you. So it could be things like if you want a specific type of firewall, maybe a virtual firewall running Barracuda, or maybe you want a, you want to use some Alert Logic security products. You can go on the Marketplace and buy them. It's not just virtual machines either. You can even buy a Cloud Guru training on the AWS Marketplace. So if your organization wants to start training everyone up in cloud and you don't want to have to go through a procurement process, you can actually go in and sign up to the Cloud Guru platform through the Marketplace and it will come off your AWS bill. And then of course it saves you a whole bunch of hassle trying to get it pushed through procurement and pushed through the learning and organization teams when it can actually just come out of your IT budget. So Marketplace is great. It provides a whole bunch or a whole suite of different products, not just virtual machines, but anything from training through to hardened operating systems, etc. So the best way to learn about Marketplace is to go in and have a look. So let's go over to the AWS console. Okay, so here I am in the AWS console. You'll be able to find Marketplace a number of different ways. You could go into EC2 and start spinning up an instance and go to Marketplace. You can also just scroll down here, AWS Marketplace. The URL is literally just aws.amazon.com/marketplace. Let's click in here. In here we can see that Marketplace consists of thousands of software listings from independent software vendors. So it's not just individual virtual machines, it's a whole bunch of everything. So it could be databases, could be business intelligence, security products, networking, DevOps, storage, media, etc. And they've got a whole bunch of categories. If we scroll down, something that makes me very proud is if we go down to featured SaaS products. We probably won't be here forever, but there's a Cloud Guru right there. So you can buy our training through the AWS Marketplace, and like I said, that will come off your AWS bill, which means you don't have to worry about getting procurement involved. So let's go over to our security products, and what we're really looking for is penetration testing, well, let's have a look at all the different security products that we have. So we split it down by vendors, we can split it down by operating systems, by pricing plans, etc., etc. AWS Marketplace is region specific, so if you buy on one region, it might not be available on another region. And here is Kali Linux. I haven't even done a search for pen testing, but Kali Linux is pretty much the industry standard for penetration testing. So it's a flavor of Linux. It comes with a whole bunch of tools built into it. Kali Linux actually have their own certification programs. I've always wanted to try and find the time to get Kali Linux certified. Might be something we add to the Cloud Guru repertoire a bit later. But check out Kali Linux. You can actually install Kali Linux on a USB thumb drive and make it bootable, and that is amazing because you can go to any computer in the world, and provided you can get the computer to boot from the thumb drive first rather than from its own hard disk drive, you can just take control of any computer. And of course, if the disk isn't encrypted at rest, you can actually go in and start accessing that computer's disk and getting files off it. Not that I'm saying you should, but I'm just telling you what's possible. Kali Linux is also great for hacking Wi-Fi. I would honestly try and hack your own Wi-Fi network. It's a program called AirCrack-NG. It is definitely a skill worth learning, and the reason it's worth learning is so you can protect against your own, you can protect your network against being hacked. So you'll learn how to, what protocols that you should use to make it super secure, and then also what Wi-Fi passwords you should use in order to, stop yourself from getting hacked. You basically don't want to use dictionary-based words, or if you do, you want to make them as long as possible. There's a website called, I think it's called cloudcracker.com. Cloudcracker.com has actually been taken down now. Online Hashcrack is apparently the newest one. This is basically where you just upload you basically capture a Wi-Fi hash. Again, if you just Google aircrack-ng, it'll teach you how to do this. But once you've got that hash file, you can upload it to sites like this, and they will basically just look up to see if that hash has been cracked before, and then it will give you what the Wi-Fi password is. So it's really, really fascinating stuff. For that reason, you should use as much random letters and numbers as possible for your Wi-Fi password. So back to the AWS Marketplace, you can go in and click on the Kali Linux, and you could go and provision a Kali Linux VM on AWS as an EC2 instance if you want. I would actually highly recommend going to Kali Linux's own website and downloading this and installing it on a USB drive if you want to play around with it. Again, it's completely beyond the scope of this course. You might be wondering, what does any of this have to do with the Certified SysOps Administrator Associate exam? And that's a very good question. So if you just Google penetration testing AWS, you'll get this landing page. And I want you to scroll down to the very bottom. And in here it says vulnerability and penetration testing. Please complete and submit the AWS vulnerability penetration testing request form to request authorization for pen testing to originate from any AWS resources. There are several important things to note about penetration testing request. Permission is required for all penetration tests, right? Permissions required for all of them. Doesn't matter if you download the software off the marketplace. That doesn't mean that it's pre-approved for you to go in and do pen testing using Kali Linux because you bought it on the marketplace. You still need to get permission. You need to get permission from AWS, and you do that just by clicking on this form and going ahead and filling it out. And that is basically where you're going to see this in the exam. You're going to get a bunch of different scenario questions. It might be asking you about the best way to implement a security solution. Marketplace may be one of the options there for you. So if that's the case, go ahead and use Marketplace. But just because you're using a Marketplace product does not mean that AWS have given you prior authorization or approval to do penetration testing using that product. You still need to go through and submit a vulnerability / penetration testing request form. So it's pretty simple. What are my exam tips? Well, you can purchase security products from third-party vendors on the AWS Marketplace. These can be things like pen testing, so things like Kali Linux, could be monitoring and alerting, like AlertLogic, for example. You can purchase things like firewalls, hardened OSs, web application firewalls, antivirus, security monitoring, as well as CloudGuru training. And it's also can be free, hourly, monthly, annual, or bring your own license, etc. And you can also, there's a place called the Center of Internet Security. They basically will go through and have a look at, let's say, like Windows Server 2012 or Windows Server 2016, and how you can harden those images. Or how you can harden those operating systems. And they actually will go through and do all the hardening for you, and then you can actually just buy the hardened image as an Amazon machine image, so you don't have to go through and do any of the hardening for you. You can just buy the hardened Amazon machine image and deploy it. So that's the Center of Internet Security Operating System Hardening. So just bear it in mind that there is a marketplace out there to buy security products. If you buy a security product, it doesn't mean that, especially when it comes to penetration testing, it doesn't mean that you're automatically authorized to use it. You still need to fill in that request form. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at identity access management, and specifically, we're going to create a custom policy, and then in the next lecture, we're going to assign this to an EC2 instance, and we'll be able to see what effects it has and how quickly it takes effect when we make changes. So this is a lab, and you will need to log into the AWS console. Okay, so here I am in the AWS console. I can find Identity Access Management under Security, Identity, and Compliance by clicking on IAM. And then I want to go ahead and click on Policies. Now we can see here a whole bunch of policies, and you can actually sort by job function. And you also notice that there's an icon here, the little AWS icon. That simply means it's an AWS managed policy. When you create your own custom policies, you won't have the AWS icon. That's because you are managing the policy yourself. So go ahead and click on Create Policy. Now you can either create the policy using JSON or using the visual editor. The visual editor is probably the best way to go about it. In here we're going to choose a service. I'm going to type in S3, not S4. And I'm going to then add some actions. So we've got all S3 actions, or we can do it by access level. And if you actually drill down, you can see the different levels of access. So we could just say, okay, I just want to be able to list buckets, and that's it. What I'm going to do is I'm going to give it all list and all read permissions or access levels, but I'm not going to give it write or permission management. Down here we need to go ahead and click on the little icon, and this is what resources that we're going to allow it to do. So in here we're going to do it, do you want it to a specific bucket or even to a specific object, or do you want it to be allowed on all resources? I'm going to click on all resources, and that's it really. So my service is S3, I'm going to allow list and all these list permissions and read and all these read permissions, and I'm going to allow it on all resources. Go ahead and hit review policy. We're going to give this a name. I'm going to call it my custom S3 policy, and in the description we're going to call it a custom policy to allow reading and listing of objects in S3 but no writes, something like that. And I'm going to go ahead and create the policy. So we have now created the policy, and we can actually type in here, if we type in custom, we can see it in here, my custom S3 policy. We can see that it's customer managed, not AWS managed. And if we actually click on here, we'll be able to see the JSON. So we can see in here, we've got the version, we've got the unique ID, we've got effect, allow, and then action. So we're going to allow all these actions on any resource within S3. So that's all it is, really, really simple. What we're going to do now, so we're just going to go ahead and create a role. And I'm going to allow this role on EC2, and I'm going to go and add my permissions. So when you add your permissions, you're just adding a policy. So in here we'll do custom. So we want my custom S3 policy. I'm going to go ahead and hit next and review. I'm going to call it my custom S3 role. And I'm going to go ahead and create the role. So now that we've created the role, we are able to assign that to an EC2 instance. Before we go in and do that, we'll do that in the next lecture. Let's go over to S3, and we're going to create 2 buckets. So I've already got a whole bunch of buckets in here. I'm just going to create a bucket and call it my custom S3 bucket A Cloud Guru, and then the region, I'm going to do it, I can't do a dash or an underscore, so the region is US East 1, and so I'm creating this in Northern Virginia, and I'm actually just going to copy and paste this bit. So I've got it in my clipboard. So I'm going to go ahead and hit create, and then I'm going to create a new bucket, my custom A Cloud Guru bucket, and I'm going to create this in the London region, which is where I am. So this will be EU West and then 2, because EU West 1 is Ireland. And I'm going to go ahead and hit create. So I've got my 2 buckets that I've created. You can see them here. So my custom S3 bucket, A Cloud Guru, US East 1, and EU West 2. And we're going to use these in the very next lecture. So that is it for this lecture. You've just learned how to create custom policies. Custom policies are policies that you manage. AWS policies are policies that AWS manage. Really, really simple to create, especially using the visual editor. In the next lecture, we're going to create an EC2 instance, and we're going to see how any changes to these policies, how quickly they take effect. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to provision an EC2 instance, and we're going to apply the role that we just created in the last lab with our custom policy to it. Then we're going to try and access S3 using that EC2 instance, and we're going to try and write to those S3 buckets, and when that doesn't work, we're going to change the policy and see how quickly it takes effect. And these are all important topics for your exam. So if you've got the time, please join me in the AWS console. Okay, so here I am in the AWS console. I'm going to go over to EC2, which is under compute, and we're going to go ahead and provision an EC2 instance. I'm going to keep it really, really simple. I'm going to use the Amazon Linux AMI. I'm going to go ahead and hit next. I'm not actually going to attach a role to this instance just yet, so I'm just going to go ahead and hit next. And I'm going to leave everything as default, maybe add a tag, we'll call it name, and my value will be my CLI test. So we're going to be testing the CLI. Let's configure a security group. My security groups right now actually I don't have a web DMZ that allows port 22, because if you remember from the config demo, we created a rule that basically stopped port 22 from being open to the world. So I do need to go in and add that. I'll quickly do that in a bit. So it will give me a warning here just saying, look, you don't have access to port 22. You need to add that in. So I'll do that as soon as I get a chance. And I'm going to go ahead and launch my instance, and I'm going to go in and view my instances. It's going to take a couple of minutes to come up. While we do that, let's just go over to our web DMZs. If you don't have port 22 open because of the AWS Config Lab, just go ahead and open it up. So SSH, and you can open it up I'm just going to open up to anywhere. I'm just going to annoy config. It'll probably actually send me an alert, but oh well. And I'm going to go ahead and hit save. So that has now opened up port 22 to the world, and I'm going to grab my public IP address, and I'm going to go ahead and SSH into this EC2 instance using terminal in Mac. If you don't have a Mac, you can just go ahead and use PuTTY. Just go in and hit connections connect, and it will give you instructions on how to connect using PuTTY, or you could also use a Java SSH client directly from your browser. It's entirely up to you. So let's go ahead and log into this EC2 instance. Okay, so here I am in my terminal window. I'm going to go ahead and just type in SSH ec2-user and then @ and my public IP address -i and then the name of our key pair. So mine's called my key pair PEM. And it says, are you sure you want to continue connecting? I'm going to type yes. And then I'm going to elevate my privileges to root, and I'm going to go ahead and clear the screen. So right now, if I type in AWS S3 LS, so I want to list my S3 buckets, it says unable to locate credentials. You can configure credentials by running AWS configure. So I'm back in the AWS console. If I go over to Identity Access Management and I go over to users, I could add a user. We could call it EC2-user, and I want programmatic access, and go ahead and hit next. And I could add this to a group. I've created an administrator group which has the full admin access policy attached to it. I could go ahead and hit next to review, and I could go ahead and create that user. That's going to give me a access key ID and secret access key. If I ran AWS configure in the terminal window, I could enter in that access key ID and secret access key, and then that would store the credentials locally on my EC2 instance, and then I would be able to go in and do anything that I wanted because that user has full admin access. We're not going to do that, however. We're going to add a role. We don't want to store user credentials on EC2 instances if we can avoid it, because it is a security risk. If that EC2 instance gets compromised, that means that somebody could get our access key ID and secret access key, and they could use that anywhere in the world on any virtual machine with the AWS or any machine with the AWS CLI installed on it. So, from a security perspective, it's always best to use roles rather than secret access keys and access key IDs. So we've got our instance in here. Now you may have done the SysOps Administrator Associate exam a couple of years ago, and you're up for renewal, and back then you could not attach a role to an existing running EC2 instance. Instead, you had to create an entirely new instance, and roles could only be attached when you were creating an EC2 instance for the first time. That is no longer the case. You can attach a role at any given time, and the way you do that is if you just go over to Instance Settings, and you can go in and click in here, Attach Replace IAM Role. We click in here, and we're going to use my custom S3 role. So I'm going to attach it to my EC2 instance, and I'm going to go ahead and hit Apply. You can see here it says IAM role operation succeeded. Let's go back over to terminal. Sometimes this can actually take a couple of minutes to take effect, believe it or not. Sometimes it's instant, just really depends. Straight away we can see it's more or less instant. So I didn't pause the video or do anything there. It was I was able to list everything in our S3 buckets. So you can see here I've got my two S3 buckets. I've got my custom S3 bucket, a CloudGuru EU West 2, and then US East 1. If I just go ahead and let's just type in ls in this directory, you can see it's empty. If I go in and echo hello cloud gurus, and I'm going to output that to hello.txt. So all I'm doing is creating a txt file that says hello cloud gurus. If I type in ls, you can now see that file. So I've just cleared the screen, and then what I'm going to do is I'm going to type AWS S3 and then copy. and then we're going to copy the home EC2 directory /hello.txt, and we want to copy that to my custom S3 bucket, A Cloud Guru US East 1. So I'm going to go ahead and hit enter, and we've had an upload failed, and it says an error occurred, access denied when calling the put object operation, access denied. And of course that's because we don't have the ability to write to our S3 buckets. So let's go back over to IAM. So I'm back in the AWS console. I can find IAM under Security, Identity and Compliance. Let's click in there. And then what we want to do is we want to go over to our policies. Now remember, our policy is attached to our role. So we don't need to do it, and our role is attached to our EC2 instance. So really all we need to do is go in and change this policy. We can go ahead and hit edit policy. We can use the visual editor or we can use JSON. I like the visual editor because I'm a visual kind of guy. And I'm going to go in and edit, and I'm going to change this to write. I'm going to go ahead and hit review and hit save. So that has now saved. Let's Alt Tab straight over and do the same command. And look, we still had an upload fail. So it's not instantaneous, but I'm not going to pause the video. I'm just going to give you a realistic. So it took maybe 1.5 seconds for the, the changes to take effect, but it has now uploaded it to S3. So if I was to type AWS S3 and then LS and then S3, and then the name of the bucket was my custom S3 bucket, A Cloud Guru, and then US East 1, and hit enter, we can now see that that object is inside our S3 bucket. Now if we do the exact same command and we do AWS S3 copy, so we're going to copy hello.txt to my custom S3 bucket, A Cloud Guru, but rather than it being US East 1, I'm going to change this to EU West 2. Okay, so we definitely have permissions to do this. All we're doing is changing the bucket name, and we're hitting enter, and that has now uploaded. So it works immediately across all buckets, across all regions. Sometimes if you do get an error message, you may have to specify the region. So you may have to do the region flag and then EU, then -west, and then -2. And that would then get around, you'll get some kind of weird error just saying that you've had some authentication error. We don't need to do that for EU West 2 currently, but that is something that you should just be aware of. So the point of this exercise is custom policies. You can create custom policies. You then manage those policies. AWS don't manage them. You can apply them to roles. Roles you can now apply to EC2 instances as soon as they've been running. After they've been running, so you don't need to do it when they've been first provisioned. And then of course any change to a policy will take effect almost immediately. It wasn't quite immediately, but it's within a couple of seconds. So let's go ahead and have a look at my exam tips. So what are my exam tips? Well, you can create custom policies using the visual editor or using JSON. You can now attach roles to EC2 instances at any time using the command line or the AWS console. Once attached, the role takes effect immediately, and any policy change also takes effect immediately once attached to the role. And you always basically, you create a role, attach a policy to the role, and then you attach the role to your EC2 instance or other AWS service that's using the role. So that is it for this lecture, guys. In the next lecture, we're going to have a quick look at IAM and multi-factor authentication. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. This lecture is on multi-factor authentication and reporting with Identity Access Management. I'm sure all of you already know how to create MFA on your root account, but do you know how to do it for individual EC2 users? And do you know how to do it via the console and also via the CLI? And also, do you know how to pull out reports on who has MFA turned on and who does not? If you do know the answer to all these things, you can skip this lecture, but if not, please join me in the AWS console. Okay, so here I am in the AWS console. Straight away I can see I don't have MFA enabled on my root account. I can go ahead and click on Manage MFA. I want to use a virtual multi-factor authentication device. I'm going to go ahead and hit Next. And all I need to do is download Google Authenticator onto my iPhone or Android and basically scan that QR code. It will then generate two codes for me, and then I'll be able to activate MFA on the device. What a lot of people don't know though is if you actually take a screenshot or even just a photo of that using your phone, you can go back. So if you lose your MFA device, so say you lose your iPhone or your Android tablet and suddenly you no longer have access to Google Authenticator, you can actually just create a new Google Authenticator on a new phone and just scan that same QR code, so the one that you've saved, and then you'll be able to log into your AWS account again. Now, not a lot of people know that, including some very smart people working in security. So it is worth saving these QR codes when they're generated because you only ever see them once. Once you leave this screen, you won't see it again. So bear that in mind. That's how we do it on the root account. How do we do it on individual users? Well, let's go ahead and create a user. I'm going to add my user. I'm going to call it EC2-user. And I'm just going to allow programmatic access. I'm not going to allow anything else. Now I have created administrator group. If you haven't already created one before, let's just go ahead and hit create group. I'm going to add admin access, and we're just going to call it my admins or something like that, and create group. And then basically anyone inside this group will have administrator access. So I'm going to go ahead and hit next. And I'm going to go ahead and create my user. So I've got a new EC2 user who's a member of the admin group. I am going to download these credentials as a CSV file, and we will come back to that in a little bit. I'm going to go ahead and hit close. Now with this user, how do we add MFA to this individual user? Well, if we click on here, there's a couple of ways we can do it. We can do it using the AWS console, or we can do it using the command line. I'm going to do it starting with the AWS console. So I can click in here to security credentials, and you'll be able to see here it says assigned MFA device. Currently is no. If you click the little edit button, again it's exactly the same process. So you go ahead and hit next, scan this QR code, put it into Google Authenticator, enter in the authentication codes, and you are good to go. How do we do it via the command line, however? Well, that's really interesting. First of all, you're going to need a command line with full access to identity access management. So we had that little EC2 instance that had a role on it, but the role in the last lecture was only allowing us to use S3. What we're going to do is let's go over to that EC2 instance, and we'll just detach that role from it. So if we go to EC2 running instances, mine was called my CLI test. If I just go over to my instance states and I want to attach replace IAM role, and all I want to do is just say no. Let's remove that role from it. So we're going to remove that role from it. Now what I'm going to do is I'm going to SSH into that EC2 instance. Okay, so here I am in the AWS console. I'm going to type in SSH EC2 and then -user and then @ and then my public IP address and then -i and then it was my keypair.pem, actually it's capital P.pem, and that's it. I'm going to hit enter, I'm going to hit yes, I'm going to elevate my privileges to root, and I'm going to go ahead and clear the screen. So currently there's nothing in this directory. What I want to do is if I type in AWS S3 LS, we have detached that role now, so I shouldn't be able to do anything. I'm not able to do anything with IAM or the AWS command line. So I'm going to run AWS configure, and I'm going to cut and paste my credentials that we just created earlier that I downloaded. Just going to paste in my access key ID. I'm going to paste in my secret access key, but I'm not going to show you what it is. I'm just going to go ahead and hit enter. And it doesn't matter, I'll show you what it is because I'm going to delete it anyway. My default region is US East 1 and my default output is just going to be enter. So there we go. I'm going to go ahead and clear the screen. I'm now going to run AWS S3 LS. I can now see all of my S3 buckets. So I have full admin access to not just S3 but to all of AWS. So the next thing is we're going to run a couple of commands, and these are available in the resources section of the course. Okay, so this will be available in the download section of the course. So the very first command we're running is AWS IAM create virtual MFA device. I'm going to create this device. And it's going to be a virtual MFA device. The name is going to be our username, so EC2-user. We're going to output the actual QR code as a PNG file to our home EC2 user directory, and then we're going to run a bootstrap method called QR code PNG. So let's copy that into our clipboard, go back over to our terminal window and run that command. And if we type in ls now, we'll be able to see our QR code, which is just sitting there. Now what we might want to do is we just want to run AWS S3 and then copy, and we want to copy this to our S3 buckets. I'm just already forgotten the name of my S3 bucket, so if I type in AWS S3 ls, it was called my custom S3 bucket. So if I do AWS S3 copy, and then it was home, then hyphen EC2 hyphen user, and then / and called QR code.png. And then I want to copy that to S3 and then my bucket name. So I'll do my custom S3 bucket, a cloud guru, and then US East 1. Go ahead and hopefully that will work. Yep, so it's uploaded it to my bucket. What we can now do is just go over to our browser and grab that QR code. So I'm back in the AWS console. We're going to go over to S3, which is always under storage. And I'm just going to go in and grab that QR code. So US East 1. I could download it. I'm actually just going to be a bit lazy and make it public. So if I go in here and just change to make public and go ahead and make public, then going to be able to click on it and I'll be able to view the QR code. So I'm now going to put that into Google Authenticator. Okay, that is now in Google Authenticator. If I go back over to my next line of code in here, before I do that actually, let's just go back over, click back to go into my S3 bucket. If I go back over to Identity Access Management in here, click on Users, and then I go ahead and click on EC2-user. And in here I can click on my security credentials. Here you can see that there's no assigned MFA device. What I'm actually after is this ARN, and specifically I'm after this number. So I'm after the 63, 71, etc., etc. So what I'm going to do is just copy and paste this into my clipboard. And I'm going to go in and so I'm back in Text Wrangler. If I just paste it in here, all I need is this actual number. I don't need anything else. So I'm going to copy this number into user number here. And I'm going to paste that into there. And then the actual authentication code, I need to enter my 2 codes. So I'm just going to open up Google Authenticator on my phone. Give me 1 second. Okay, so I'm entering in code 1 here. So my code 1 is 434121. I'll wait for it to change, and we enter in code 2 here. So it's just about to change, and the new number is 827407. So that is AWS IAM enable MFA device, the username EC2-user, the serial number, the ARN of the device, which is basically just going to be our username here, then MFA, then hyphen, and then our username, and then the 2 authentication codes. Now this is really time sensitive, so let's go and copy this straight into AWS CLI. And there we go, that has hopefully created our MFA token. If we go back over to here and hit refresh, we can now see it's assigned an MFA device. So here it is in here. We have now created an MFA device using the command line. So we've enabled MFA using the command line. We've also had a look at how we can do it using the console. You can also make sure that every time you use the command line that you're authenticating with multi-factor authentication. In order to use the command line with MFA, you need to run this AWS STS get session token. So you're using security token service. Basically, I'll leave a link to this article in the notes below, or in the resources section. Do bear that in mind going into your exam, that you can enable MFA for the command line, and in order to use the command line with MFA, you are going to have to get temporary tokens using the security token service. Final thing I want you to know from this lecture, I'm just going to go back over to users. I always get really paranoid whenever I show someone my secret access key and my access key ID and secret access key on videos. Amazon have actually caught me out before where I've gone in and forgotten to delete it and then published a lab that was live, so anyone could have done anything to my AWS account. Thankfully it was the AWS security team who picked it up, and they actually emailed me directly and said, Ryan, what the hell are you doing? So I have deleted that now, so you won't be able to steal my access key ID and secret access key. One last thing I want to show you is this, the credential report. report. So the credential report will show you basically all the users that you have and whether or not they have access or whether or not they use MFA. And this can also be a really important exam topic. So let's open this up. It comes down as a CSV file. So I've opened this up in Excel. We can see in here my users, my Amazon resource names, the time, the user creation time, password enabled, whether or not it's enabled, last time password was used, etc., etc. And in here we've got MFA active. So right now my 3 users, my root account, my laptop, and my Office iMac do not have MFA enabled on there. So you can create reports within IAM that can tell you a whole bunch of things, and this is also an important exam topic. So let's go ahead and have a look at my exam tips. Okay, so what are my exam tips? Well, you can enable multi-factor authentication using the command line and also by using the AWS console. It can be enabled on both the root account as well as user accounts, and you can actually enforce the use of MFA with the CLI by using the Security Tokens Service, or STS, and the link is below on how to do that. And then also remember going into the exam that you can report on who is using MFA on a per user basis using the credential reports within IAM. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. So this lecture is on STS, or Security Token Service. We sort of had a brief look at it in the last lecture where we use STS to authenticate us when using the command line with multi-factor authentication. It's also used for a whole bunch of other different purposes, but mostly, I mean, the whole point of STS is it's used to grant users limited and temporary access to AWS resources. And your users can come from 3 sources. So they can come from federation. So federation just means you're federating or you're cooperating with some other form of authentication service. And typically this would be Active Directory. And hopefully all of you know what Active Directory is, but you know, when you sign into your Windows PCs at your office and you're entering in your SSO or single sign-on, that is just basically federating with a service called Active Directory. It's one of Microsoft's most famous services. So federation typically is done with Active Directory, and it uses a security assertion markup language, or SAML, and this basically grants temporary access based off the user's Active Directory credentials. So the users don't need to be a user in IAM when you federate with Active Directory. They just need to be a user within your Active Directory environment. And single sign-on allows users to log into the AWS console without assigning an IAM credential. So that's what Security Token Service helps to enable. Basically, and we'll show you how it works in a second, but basically you can just sign into the AWS console using the same username and password that you would sign into when you sign into your workstation in the morning. You can also use STS to federate with mobile apps, so you can use it, you can use your Facebook login or your Amazon credentials or Google or anything else that's supported by OpenID providers, and STS will grant you temporary access to the AWS resources. And you can also use STS with cross-account access, and cross-account access lets users from one AWS account to access resources in another. So just let's understand some key terms before we continue. So federation, like I said, is just combining or joining a list of users in one domain, such as IAM, with a list of users in another domain, such as Active Directory or Facebook or your Amazon credentials or your Google credentials or LinkedIn or whatever. An identity broker is a service that allows you to take an identity from point A and join it or federate it to point B. An identity store is just services like Active Directory, Facebook, Google, etc. It's where you're going to store all your identities. And then your identities themselves are just a user. So identity is a user. They're all stored in an identity store like Active Directory or Facebook or whatever. And then you create an identity broker, and that basically allows you to take those identities in your identity store and join them up to Identity Access Management. And that's essentially the federation of it. So you're federating or you're joining IAM with your Active Directory or Facebook etc. And the service that allows you to do that is Security Token Service. So once it's all broken down, it becomes a lot easier. So let's do a scenario. You're hosting a company website on some EC2 web servers in your VPC, and users of the website must log into the site, which then authenticates against the company's Active Directory servers, which are based on site at the company's headquarters. Your VPC is connected to your company HQ via a secure IPsec VPN. And once logged in, the user can only have access to their own S3 bucket. How would you go about setting this up? Well, basically, we do it using this diagram. So we've got our employees and we've got our enterprise reporting applications. This could be our, essentially this would be our web application. Then what we want to do is go ahead and create an identity broker. And so our identity broker is just going to essentially join Active Directory to our identity access management. So this is something you're going to have to develop yourself. But basically our identity broker is going to authenticate against Active Directory first. Really important to remember that. And then once that has credentials, it's going to be passed a token from Active Directory, and it's going to pass that to the Security Token Service, which is then going to give us another token. So it authenticates with Active Directory first, then it authenticates with STS. Once we have STS, we can, our STS token, we can then pass that back to our custom web application or our enterprise reporting application. That's then going to authenticate against S3. And when we authenticate against S3, it's just going to look at our STS and our username and say whether or not it's a valid user, which it will be. And it's doing that using Identity Access Management. And then once that's done, we're able to access S3. So it is pretty simple. It's just important to remember the steps that basically you always authenticate against Active Directory first, or against Facebook first, or against Google, or whatever. So the third-party authentication provider first. We then will authenticate or take that token to the AWS Security Token Service. It's going to give us a temporary access to our AWS environment. And then when we go and access S3, basically S3 is going to ask us for our username and our temporary STS token, and it will then check that against IAM, and if everything's in order, it will give us access to S3. So I've just run through that, I've explained it, but here are the bullet points. So employee enters their username and password, the application calls an identity broker, the broker catches the username and password, the identity broker then uses the organization's Active Directory to validate the employee's identity. The identity broker then calls the get federation token function using IAM credentials. The call must include an IAM policy and a duration, which can be 1 to 36 hours, along with a policy that specifies the permissions to be granted to the temporary security credentials. So you have to have the policies set up in IAM. Security Token Service then confirms that the policy of the IAM user making the call to get federation token has permissions to create new tokens, and then returns 4 values to the application. Those 4 values are an access key, a secret access key, a token, and a duration, so the token's lifetime. And that lifetime is always going to be 1 to 36 hours. The identity broker then returns the temporary security credentials to the reporting application, so this is to our custom web application. The data storage application then uses those temporary security credentials, including the token, to make a request to S3, and then S3 uses IAM to verify the credentials and to allow the requested operation on the given S3 bucket, and then IAM provides S3 with a go-ahead to perform the requested operation. So what are my exam tips? Well, just remember how this works from a high-level point of view. So you've got your employees, they're trying to log in the morning, you've got your custom web application here that you've made yourself, you've got your identity broker here that you've made yourself. The identity broker basically takes their username and password, it checks it against whatever your user directory is. So in this case it's Active Directory, it could be against Facebook, it could be against LinkedIn, whatever it is you're using to verify your credentials. If those credentials are correct, it will then authenticate against that, and it will then authenticate using the AWS Security Token Service. The security token service is going to give it 4 different items. You won't need to remember them all for the exam, but essentially it's going to give you a token, and a token that has a time limit on it, so you're only getting temporary permission to access the AWS environment. Once you've got that token, you're then going to pass that back to your application. Your application is going to try and access S3, and it's going to pass it the STS token. That's going to be checked by IAM and just make sure that the token is valid, and if it is, you'll get access to S3. So you just need to remember going into the exam how STS works at a high level. You're going to get a bunch of different scenario questions, and they're going to try and mix these steps up. So just remember, it's really simple. Authenticate against whatever it is you want to authenticate against first, so whether it's Active Directory or Facebook or whatever. So you authenticate against the third party first. Then you authenticate against STS. STS will give you a token. Then when you try and access your AWS resource, whether it's S3, DynamoDB, whatever, that resource will quickly just check that token against IAM, and if everything's correct, it will give you access to the platform. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture we're going to look at logging. Now we have done a monitoring and reporting entire section. In this case we're actually going to look at logging and how it relates to security. So there's really 4 services you need to be aware of going into your exam that involve security and logging. So the first, of course, is CloudTrail. So CloudTrail records all API calls. AWS Config then records configuration, so the state of your AWS environment and what it looks like at that time. So you can go back 2 weeks ago and have a look at your security groups. CloudWatch logs reports basically, CloudWatch, so your performance metrics, etc. And then we've also got VPC flow logs. So VPC flow logs we will cover in the VPC section of the course, but essentially it's network traffic across your VPC. I would recommend going and reading the white paper Security at Scale Logging in AWS. I certainly would recommend doing that for the security specialty because that is a really important white paper. You probably don't need it for SysOps Administrator Associate, but it's probably worth having a read anyway. It was developed using ISO 27001, PCI DSS version 2, note that we're on 3.2 now, as well as FedRAMP, and it looks at common logging requirements. And here is the link below. We'll leave that as a resource in the resources section of the course. Remember that you should always control access to your log files from a security point of view. So you should always prevent unauthorized access to your log files, and you can do that in a number of ways. So you can do that by using IAM, users, groups, roles, and policies. So you can restrict access to S3, for example, using users, groups, roles, and policies. You can then also just have S3 bucket policies, restricting access to individual buckets. And you could also turn on multi-factor authentication so that if users do go into those S3 buckets and try and delete, they have to enter two-factor authentication in order to do it. You should always ensure role-based access, and by that I'm not talking about roles within IAM, I'm talking about roles within your organization. So who actually has access to your log files? Well, it should only really be your security guys, right? Or maybe your sysadmins. It shouldn't be your developers necessarily. Should definitely not be finance or your sales guys or your marketing guys. They shouldn't be able to access your S3 logs. And of course you can restrict based on roles using IAM users, groups, roles, and policies. You can also use Amazon S3 bucket policies as well. You should also obtain alerts on log file creation as well as misconfiguration. So you should alert when logs are created or if they actually fail. And you can do this using CloudTrail notifications as well as AWS config rules. And alerts should be specific but not to divulge details. So CloudTrail SNS notifications would only point to a log file location, wouldn't necessarily tell you what those logs are about. You should also manage changes to your AWS resources and log files. So log changes to system components, and of course again we would use config rules to do that as well as CloudTrail. So config rules will log configuration changes, whereas CloudTrail will log API calls. So if somebody gone in and created a new S3 bucket and move log files over from one S3 bucket to another to have a look at them. And you should also put controls in place to prevent modification to logs. And you can do this using IAM and S3 controls and policies. You can also do this using CloudTrail. CloudTrail comes with log file validation and log file encryption. So you can actually validate the logs within CloudTrail itself. And if somebody has gone in and modified that, you can actually see whether or not somebody has modified that using file validation. We cover that in the Certified Security Specialty, how to go about doing that as well. So do bear that in mind. So what are my exam tips? Well, just remember the main services for logging in terms of security is going to be CloudTrail. CloudTrail monitors your API calls. Then have AWS Config, which is like a big CCTV camera recording the exact configuration of your AWS environment as it exists today, and then alerts you to any changes. We also have CloudWatch logs, and then we also have VPC flow logs, which we are going to cover in the next section. And I will just remind you again of this slide that we had, I think it was in section 2, monitoring and reporting section. So CloudWatch always monitors performance, CloudTrail monitors API calls in the AWS platform, and AWS Config records the state of your AWS environment and can notify you of changes. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at AWS WAF, or Web Application Firewall. Now, this does come up in SysOps quite briefly, but it definitely is a heavy focus in the Certified Security Specialty. But for SysOps, basically, you just need to know what it is and what it integrates with. So a WAF is a Web Application Firewall that lets you monitor the HTTP and HTTPS requests that are forwarded to Amazon CloudFront or an application load balancer or to API Gateway. And AWS WAF also lets you control access to your content. You can configure conditions such as what IP addresses are allowed to make this request or what query string parameters need to be passed for the request to be allowed. And then the application load balancer or CloudFront or API Gateway will either allow this content to be received or it will give it a HTTP 403 status code. So at its most basic level, AWS WAF allows for 3 different behaviors. It allows all requests except the ones that you specify. It blocks all requests except the ones that you specify, or it counts the requests that match the properties that you specify. So you can allow everything, you can block everything, or you can just count the requests that match the properties that you specify. Now you're probably wondering, well, what properties can I specify? Well, you can specify things like IP addresses that requests originate from, countries that requests originate from, values in your request headers, strings that appear in requests, either specific strings or strings that match regular expression or regex patterns, the length of the request, more importantly, presence of SQL code that is likely to be malicious, and this basically stops SQL injections, or the presence of a script that is likely to be malicious, and this basically stops cross-site scripting. So you can go in and configure the WAF to monitor all of these things, and then it can either allow everything, block everything, or just count the number of requests. So that's all a WAF is. It's a layer 7 firewall, it's application aware, and it gives you a lot more security than just a standard firewall. Now, where this comes up in SysOps Administrator Associate exam is you need to know which services it integrates with. So it integrates with application load balancers, with CloudFront, and with API Gateway. It does not integrate with classic load balancers and network load balancers. It needs to have an application aware or a layer 7 load balancer, so application load balancers, because a WAF is basically a layer 7 device. It's able to see inside your traffic. So that's really, really important to remember going into the exam, is that WAF integrates with application load balancers, CloudFront, and with API Gateway. You can't use it with classic load balancers or network load balancers. So onto my exam tips. Just remember that what AWS WAF is. It's a web application firewall that allows you to monitor the HTTP and HTTPS requests that are forwarded to Amazon CloudFront or to an application load balancer or to API Gateway. It allows you to control access to your content, and it does not integrate with classic or network load balancers. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to talk about AWS's hypervisors, isolation of AWS resources, and AWS firewalls or security groups. So let's start with what a hypervisor is. And if you go to Google and just type hypervisor in, you'll get the Wikipedia definition, which is a hypervisor or virtual machine monitor is a computer software, firmware, or hardware that creates and runs virtual machines. A computer on which a hypervisor runs one or more virtual machines is called a host machine, and each virtual machine is called a guest machine. So basically a hypervisor is the physical host that is going to run your virtual machines, like so. So EC2 currently runs on the Xen hypervisor, and Amazon have been using Xen for years and years and years. However, there is a little catch. C5 instances have just been launched, and in that launch they accidentally, I don't know if it was an accident or not, but they said that the C5 instances were running on KVM. Now that's a big shift if they're going to suddenly go and change hypervisors, because if you think about the number of like physical machines they have all around the world, managing a new hypervisor or switching to a new hypervisor would be a very big project. As soon as that got leaked from the blog, Amazon went in and actually deleted the blog. I'm wondering if they're waiting to make this announcement at reInvent, but the register basically managed to capture the before and after, so by then it was already news. Let's wait and see what happens at reInvent, but the C5s they did announce is running on KVMs, but everything else is on Xen hypervisors. So Xen hypervisors have guest operating systems running either as para virtualization or using hardware virtual machines, so PV or HVM. And you can see that when you go in and try and provision your EC2 instances. Some will say HVM, some will say PV. HVM, you can basically only have Windows on HVM. PV, you can have Linux instances. So HVM guests are fully virtualized. The VMs on top of the hypervisors are not even aware that they're sharing processing time with other virtual machines, whereas PV is a lighter form of virtualization, and it used to be a lot quicker. However, this performance gap's basically closed now, and Amazon now recommend using HVM over PV where possible. It's also worth, like I said, noting that EC2 instances, Windows EC2 instances can only be HVM, whereas Linux instances can be both PV as well as HVM. Para-virtualized guests rely on the hypervisor to provide support for operations that normally require privileged access. So the guest operating system has no elevated access to the CPU. The CPU provides 4 separate privilege modes, 0 to 3, and these are called rings. And ring 0 is basically the most privileged, whereas ring 3 is the least. And the host operating system, so the Xen hypervisor itself, is going to be executing in ring 0, but the actual guest operating system will be executing in ring 1, and then all your applications are basically executing in the least privileged ring 3. So let's have a look at what this looks like. So we've got our rings here. Ring 0 is our most privileged, and that's where our Xen hypervisor runs. Inside ring 1, we're going to have our EC2 instances, and I should point out again, this is for PV only. So in ring 1, that's where we have our EC2 instances, and then our actual applications are in ring 3. So they're segregated by these different rings. Let's talk about isolation. So we have basically our physical interface down here. So we've got our network, our network cards, etc. We then have a firewall. The firewall itself actually runs at the hypervisor layer, and Amazon manage all that for us. And the firewall essentially allows us to create our own security group. So we've got customer 1 who's got a security group, customer 2 who's got a security group, customer 3 who's got a security group, etc. They're all isolated from each other, and they're all isolated by the firewall, which is running at the hypervisor layer. We then have our virtual interfaces. These are our virtual network cards. And then we have the actual hypervisor itself, and then we split it down into individual customers. So we've got customer 1, customer 2, customer 3, customer X, etc., etc. So when we interact with this environment, basically we're going through a physical interface, we're hitting the firewall. The firewall is then splitting our traffic, and it's completely isolating it through our security groups, through our virtual interface, through the hypervisor back to our resources. So these could be your EC2 instances, etc. So that happens, and it's done by the firewall. So it is complete isolation between customers. In terms of who has access to the AWS hypervisors, it's just administrators with business needs and to be able to access the management plane. They're required to use multi-factor authentication to get in there. The actual management plane or the hosts are purpose-built, so Amazon have gone out and built them for themselves. The hosts are systems that are specifically designed, built, and configured and hardened to protect the management plane of the cloud. All such access is logged and audited, and when an employee no longer needs business need to access the management plane, the privileges and access to these hosts and all relevant systems can be revoked. In terms of the guest operating system access, well, we all know that that's our responsibility. So virtual instances are completely controlled by us, the customer. We have root level access, and we basically connect in using our key pairs. With Linux instances, we're using SSH. With Windows instances, we're using RDP. AWS does not have any access rights to our guest operating systems inside EC2. And something else to note is just around memory scrubbing. This occurs both for disk memory as well as RAM memory. So EBS automatically resets every block of storage used by the customer so that one customer's data is never unintentionally exposed to another. Also, memory allocated to guests is scrubbed or set to 0 by the hypervisor when it is unallocated to a guest. The memory is not returned to the pool of free memory available for new allocations until the memory scrubbing is complete. So everything is scrubbed. You cannot go in and use disk recovery tools and recover some other customer's data. It doesn't work. It is scrubbed. So that is it for this lecture, guys. Just in terms of my exam tips, you'll want to choose HVM over PV where possible in terms of performance. PV is isolated by layers. Guest operating system sits on layer 1, applications on layer 3, and of course our host or our hypervisor sits inside layer 0. Only AWS administrators have access to the hypervisors. The staff don't have access to EC2. At an operating system level, that's your responsibility as a customer, and all storage memory and RAM memory is scrubbed before it's delivered to you. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture where we explore dedicated instances versus dedicated hosts. Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at the difference between EC2 dedicated instances versus dedicated hosts. So let's start with EC2 dedicated instances. What are they? Well, they're basically EC2 instances that run in a VPC on hardware that's completely dedicated to a single customer. So your dedicated instances are physically isolated at the host hardware level from instances that belong to other AWS accounts. Now, one thing you should bear in mind is dedicated instances may actually share hardware with other instances from the same AWS account that you own that are not dedicated instances. So I'll show you how we do this in a little bit, but basically when you go into provision an EC2 instance, you have the option for a VPC tenancy, and in there we always, by default, we've been using shared throughout this course. You can actually go ahead and say dedicated, and that will then make sure that you're provisioning this instance on hardware that's dedicated to you, and that everything in that VPC will be on the same hardware. So do bear that in mind. So dedicated instances, you can purchase them on demand, or you can get reserved instances and save up to 70%, or you can even use spot instances and save up to 90%. So what are EC2 dedicated hosts? Well, like dedicated instances, you can launch dedicated hosts and that physical server will be dedicated to you. However, there's an important difference between the two. A dedicated host is going to give you additional visibility and control as to how instances are placed on a physical server. And the good thing about dedicated hosts is that you can consistently deploy your instances to the same physical server over and over and over again. And as a result, dedicated hosts enable you to use your existing server-bound software licenses, and as well as addressing corporate compliance and regulatory compliance. So some software licenses like VMware or like Oracle will say that the host has to be dedicated. It can't be multi-tenanted, and you have to have full control of that host. In that case, you would use dedicated hosts. And this description is a little bit vague. I actually got it from the AWS website. So let's go over to the website now. So I'm here at aws.amazon.com/EC2/dedicated-hosts. Now, if we scroll down, they do provide us with a nice little table and makes it a bit easier to understand the differences between the two. So here's our dedicated instances, here's our dedicated hosts. With our dedicated instances, we're going to be billed on a per instance basis. With dedicated hosts, we're going to be billed on a per host basis down here. Both are using dedicated hardware, so don't get it confused. The cool thing about dedicated hosts, though, is you can see the visibility of your sockets, how many cores you've got, the host ID, etc. What the affinity is between a host and an instance. You can target instance placement, so you can keep deploying the same instances over and over and over again to the same physical server, and you can add capacity to this using an allocation request. So both run on dedicated hardware. The main thing to realize is about the visibility. That's the main difference. So you're able to see the number of sockets and the number of cores. So let's go over to EC2 and see how we provision these. Okay, so I'm signed into the AWS console. I'm going to go over to EC2. And in here, you can actually see under instances, we've got dedicated hosts. You can go in and click in here and go and allocate a host. This actually often blows my mind because it means that Amazon have data centers that have like literally physical dedicated hosts, not doing anything, just waiting for a customer to come in and, go ahead and provision it. And it is actually really, really quick to provision. You basically just fill this in and hit allocate host, and that will go in and provision your host. I'm not going to do that though because it is expensive. Well, at least to me it is. There's another way we can do it as well. So let's go over to our two instances in here. We're going to go ahead and launch an instance. In here we've got our Amazon Linux AMI. We'll go ahead and hit select. And in here, we'll just do T2 micro. And in here, this is where we can provision whether or not it's a dedicated instance versus a dedicated host. So if we just go down to tenancy in here, we've always been using run a shared hardware instance. If you click in here, you can either choose run a dedicated instance, or you can choose run a dedicated host, launch this instance on a dedicated host. So it's up to you as to what you want to do. I wouldn't go ahead and do it. It's a fairly minor point. Where they, when you go into the exam, where they might trick you up is just talking about the differences between the two. So you should have a clear understanding of what those differences are. So that brings me on to my exam tips. Both dedicated instances and dedicated hosts have dedicated hardware. So they've all got dedicated hardware. Dedicated instances are charged by the instance, whereas dedicated hosts are charged by the host. Where you're really going to see this is around, you're going to get scenario-based questions, and you've got specific regulatory requirements or licensing conditions, and it's going to ask you if you should choose spot instances, reserved instances, dedicated hosts, etc., etc. Obviously, you want to go for dedicated hosts. That's what this is built for. Dedicated instances may also share the same hardware along with other AWS instances from the same account that are not dedicated. And then remember that dedicated hosts give you much better visibility into things like sockets, cores, and the host ID. So that's it for this lecture, guys. In the next lecture, we're going to look at hypervisor security, and then we're basically almost done and we're ready to review section 4. So if you've got the time, join me in the next lecture. Okay, hello Cloud Gurus and welcome to this lecture. This lecture we're going to look at AWS Systems Manager and in particular the EC2 run command. Now we did cover AWS Systems Manager in section 2 of the course where we did monitoring and reporting. In this we're just going to look at the EC2 run command. To be honest, the Systems Manager does not form too many questions in the SysOps Administrator Associate exam, which I actually found a little bit surprising because this is the one service that you're pretty much going to use in your day-to-day running of AWS as a SysOps administrator. And it wouldn't surprise me if later on Amazon actually add more and more exam questions. I would actually love to create an entire section on Systems Manager because it is a big topic in AWS and it is really crucial to understand it if you're going to be a system admin. If you do want to learn more about AWS Systems Manager, just type in AWS Systems Manager documentation into Google and go and have a read through of the official AWS documentation. There's loads of guides and examples in there, and that's basically what I'd create a course on anyways, just following those guides. So you can just follow those guides and learn Systems Manager inside out. And I would recommend it if you're an aspiring systems admin who wants to get into AWS. Understanding Systems Manager inside out could be a key differentiator between you and another applicant. So in this lecture, we're just going to look at run command and what it is. Essentially what the EC2 run command is is it allows you to manage a large number of EC2 instances as well as on-premise systems. And essentially, it allows you to automate common admin tasks and ad hoc configuration changes. So these could be things like installing applications, applying the latest security patches, joining new instances to like Windows domain. And you can do this without having to log into each instance individually. You can do this at scale. So you can do this to 10 instances or 100 instances or 1,000 instances. And it makes sense, right? If you've got 1,000 EC2 instances running your production application and you need to make sure that Windows updates have been applied, you don't want to have to RDP into each instance. You want to do this from the console in a way that's completely scalable. So let's go ahead and have a look what this looks like in the AWS console. Okay, so here I am in the AWS console. Now, Systems Manager, you will see, has a really nice UI under Management Tools. So if you just go down to Systems Manager, you can see it in here. And you can also actually see it if you just go over to EC2 and you click on the side, you'll be able to see Systems Manager down here. So you've got your Systems Manager services and you've got your shared resources. You've got the run command in there. But it doesn't give you as a nicer UI. So you can click in here and have a quick look at Systems Manager. In order for Systems Manager to actually go ahead and work, though, you're going to need to create a role. And we're going to need to apply those roles to our EC2 instances. So let's go back to AWS before we get stuck in, and let's go over to IAM. And what we're going to do is create a new role. So click on roles and then just go ahead and hit create role. It's going to be for EC2. So click on EC2 in here and you'll see it down here, EC2 role for Simple Systems Manager. Go ahead and click on that and then hit next for your permissions. So because there's only one option, there's no checkbox. So just go ahead and click on there. You can have a look at the policy summary. You can have a look at the JSON. Once you're happy with everything, go ahead and hit next review. Role name, we're just going to say role for SSM and go ahead and create the role. So that will now give you a role for SSM, which you can see in here, and we're ready to go ahead and launch our EC2 instance. So let's do that first. We're going to launch an EC2 instance. I'm going to use a Windows instance for this. So let's go ahead and click on Launch Instances. It's going to scroll down and we're going to grab our Windows base image, so 2016 base image. Go ahead and click on that. Do a T2 micro. Leave everything as default, but add in your role for SSM. So we have that role applied. Next, we're going to add our storage. We'll do 30 gigs for the root device. Add some tags. Now you can add tags here, and it's quite important for when you're using the run command, you can base it off tags. So you could have a tag in here for something like, I don't know, run command, or SSM might be a better tag. So is SSM enabled? I don't know, whatever it is you want, and then value as yes. So let's go ahead and add in our security groups. I'm just going to use an existing WebDMZ security group. So perhaps this is a web server. Going to go ahead and review and launch. It's giving me an error because I've been mostly just using Linux machines. So SSH is open to the world, but RDP is not. This is actually a good thing, error to have though, because technically we don't want RDP access for this lab. We want to be able to just to do things through the run command. We don't want to actually have to RDP into anything. So let's just go ahead and leave that for now. And then I'm just going to scroll down and hit launch. And I'm going to create a new key pair because I actually have no idea where my Windows key pairs are, or the key pairs for this particular account. So I'm just going to call it my Windows key pair, and I'm going to go ahead and download that, and I'm going to go ahead and launch my instance. And so that is now launching. When that has come up, it's going to take a couple of minutes because it is a Windows instance. But once it has been launched, what we're going to do is we're going to go into the systems SSM portal, and we're going to use a run command. So I'm just going to pause the video. Okay, so that instance is now live. If we go back to our services and we go down to our management tool and we go over to Systems Manager, let's go ahead and hit run command, which is in here under our actions. So just click on run command. That will then take you to this splash screen, and you just can click on the runner command. I think what we're going to do, let's just pick a random one, maybe configure CloudWatch. Scroll down in here, you can see a target, so it's already being picked up, and you can do it manually selecting your instances or by specifying a tag. I'm going to do it manually and just click on this instance that we have just provisioned. You can see the instance ID in here. In here you've got some different options, so you could put in the configuration for your CloudWatch in JSON format. I'm going to leave mine as blank, and in here it's just a note about what it is you're doing. So let's just scroll back up. We're configuring CloudWatch, so let's put that in here. Configure CloudWatch. And then down here we've got a whole bunch of different options. Ones to note are SNS, so you can enable an SNS notification, so you could have it send you an email once this has been run. There's also this, which is pretty cool. So this is the actual AWS CLI command that you could use to do what we've just set up in the console. So if you do want to just get the command to reuse later on, so you don't have to go back into the console, that's the command right there. Once you're happy with everything, just go ahead and hit run. Now this can take some time. It will say overall status in progress. I'm going to pause the video, probably be about 15 to 20 minutes before I come back. I'll let you know. And then hopefully everything would have run successfully. So I'm just going to refresh the page. It's been about 5 or 10 minutes, and there we go. Overall status is now successful. So we have basically provisioned an EC2 instance. We've created our role. We've assigned that role to the EC2 instance, and then we've been able to go in and run commands against that EC2 instance. It has been successful. We haven't had to RDP into that instance at all. In fact, we didn't even enable it on our security groups. So AWS Systems Manager can be really useful using the run command, using the patch manager, using maintenance windows, state manager, etc. But let's go through what you need to understand about Systems Manager for your exam. So what are my exam tips? Well, commands can be applied to a group of systems based on AWS instance tags, or you can go in and select them manually. The SSM agent needs to be already installed on all your managed instances. It does come with that base Amazon AMI for Windows Server 2016. The commands and parameters are defined in Systems Manager document, and commands can be issued using the AWS console, the CLI, AWS tools for Windows PowerShell, the Systems Manager API, or the Amazon SDKs. And you can also use this service with your on-premise systems as well as EC2 instances. Where are you going to see the run command in your exam? Well, basically you want to go in and update, let's say, some security patches, and you want to do this at scale. How would you go about doing that? Do you script it? Do you log into each instance individually, or do you use the run command? Well, it's much easier to update instances at scale using the run command, but do bear in mind that your instances need to have SSM agent enabled, and they also need to have that role assigned to them, allowing your permissions to talk to those EC2 instances. So just understand what the Systems Manager run command is at a high level, the fact that you need that role installed, as well as having the agent installed on the instances as well, and that you can apply them to the instances by selecting them manually or by looking for specific tags. So that is it for this lecture, guys. In the next lecture we're going to look at Systems Manager Parameter Store, and we're basically coming to the end of this section of the course. In the next section we're going to look at networking and VPC. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture we're going to look at the AWS Systems Manager Parameter Store. So I want you to imagine the following scenario. So you work for a bank, you're a systems administrator, and you need to store confidential information such as users, passwords, license keys, etc. You need to basically pass this information to EC2 as either a bootstrap script, or it could be using CloudFormation, or it could be using Lambda or whatever. So how would you do this? Well, the answer is with AWS Systems Manager Parameter Store. So let's go and jump over to the AWS console and have a look at this in action. Okay, so here I am in the AWS console. So where is AWS Systems Manager? Well, it's actually under EC2. So just like EBS or load balancers, it's a function that sits under EC2. Doesn't have its own section. You'll be able to find it by scrolling all the way down here And you can see we've got Systems Manager services. So we've got things like the run command, the state manager, configuration compliance, etc., etc. And then if we scroll down under the shared resources, we've got our parameter store. So let's go ahead and click on that. Now, if you've never used it before, you're going to get this splash screen. We'll go ahead and get started. Essentially, we create a parameter. We're going to store sensitive data in there, and then we're going to be able to access this parameter across a whole bunch of different services. And you'll see the services in here. So EC2 run command, EC2 state manager, CloudFormation. You can do it using Lambda, etc., etc. So let's go ahead and get started. So in here we've got our name. So this might be our license key. Let's call it Adobe license key. So let's assume we've got some form of Adobe software on here, and we need to pass it this license key when we're installing. So my license key for Adobe. Now in here we've got different types. So we've got string, we've got a string list, and we've got secure string. With string, we can just enter any data in here. Within string list, we can basically enter multiple values, and we separate them using a comma. If you want this information, you can just click up here. And then secure string actually encrypts the data using KMS, and this is where we would store our sensitive information. And even if you type it in here, you can see it's not revealed to me. So if you have other system administrators, you can store all your keys and stuff in here, and they can go and use this and reference this, but they won't actually be able to see the keys themselves. So it is very, very secure. So I'm going to go ahead and just enter in a random one, hit create parameter. You see the parameter was created successfully. If you do get some weird error messages, it's probably because you put a space in the name. Just go back and take the spaces out. And then you'll be able to see here we've got my parameter. So it's called Adobe license key. It's a secure string type. Notice that I can't go in and actually view the value. Actually, I can here. Look, there you go. Show value. So you can see the value inside the console, but it depends on your levels of permission. So if people didn't have access to EC2, for example, they wouldn't be able to go in and see these keys. And then we can pass this attribute over to CloudFormation. We can pass it to Lambda, etc. And if you want to find out how to do that, just head over to the documentation. We've added it as a resource in the course. You can go down and see about Systems Manager, working with Systems Manager parameters. In here, you can see how you can actually organize them into hierarchies, how you can create them, which we've just done, tag them, and then working with different versions. They give you lots of practical examples, and you'll be able to see how to set things up, using Lambda, how to reference them in CloudFormation, etc. To be honest, you're not going to be quizzed on that in the exam, so it is beyond the scope of this course, but you definitely need to understand at a high level that you can use AWS Systems Manager as a way of storing sensitive information. So what are my exam tips? Well, if you've got confidential information such as passwords, database connection strings, license codes, etc., could be usernames, whatever it is that's confidential, you can store this inside SSM parameter store. You can store values as plain text, or you can actually go in and encrypt the data using KMS, and then you can use this data by referencing the values using their names. So the names do need to be unique. And you can use this service with EC2, with CloudFormation, with Lambda, with EC2 run command, etc. So be aware of that. You might get some scenario questions where you've got exactly that kind of scenario where you're working at a bank or something like that, and you need to store sensitive information. Keep in mind that AWS Systems Manager is probably going to be a better place to store it than putting it in a plain text file in S3 and giving it public read permissions. So if you do see that, just be aware of what it is at a high level. So that's it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're looking at how we can secure S3 using pre-signed URLs. So it's the very last way of accessing objects inside S3. We've looked at bucket policies, we've looked at IAM policies, we've looked at object ACLs or bucket ACLs. we've looked at CloudFront, and of course we can access objects using pre-signed URLs. Now this is typically done using the SDKs, so you would do it using Python or using Java or using Go or whatever. You generate some code that would enable your users to access a object inside S3 using a pre-signed URL. A lot of people don't know this though. You can actually do it via the command line. So that's what we're going to do in this lecture. We're going to quickly show you how to do it using the command line. So we need to log into the AWS console. Okay, so here I am in the AWS console. The very first thing we need to do is just go down to IAM. We're going to create a role which will enable us to access S3 using administrator access. No doubt some of you will already have this role installed on your AWS account from the Solutions Architect Associate or Developer Associate. I'm just going to create one anyway. So let's go in and hit create role. I'm going to go and create this role for EC2, and I'm going to just do EC2 as my use case, and then go ahead and hit next for permissions. And then I'm going to go and search for S3, and I should get something like S3, Amazon S3 full access. You can see it's an Amazon managed policy because we have the the Amazon AWS icon. I'm just going to call this S3 admin access, something like that, very original. And it is not allowing me to save this because I've already got that, so I'll just call this 2018 for argument's sake. Go ahead and hit create role. That will now create the role which I can then go ahead and assign to an EC2 instance. So let's go ahead and provision an EC2 instance. By now you should all understand how to SSH into an EC2 instance, either using PuTTY or using the Mac OS X terminal. If you don't, please go back to the associate courses and just have a quick review as to how to SSH in. I'm going to go ahead and launch an instance. I'm going to use the Amazon Linux AMI. I'm just going to use a T2 micro. I'm going to use everything as default, but I'm going to add that S3 admin access role that I just created. I'm going to go ahead and hit next. I'm going to add my tags. I'm just going to leave everything as default. Select an existing security, or create a new security group if you don't already have one, or select an existing one. Make sure that port 22 is open to the world, or at least open to your IP address so you can SSH in. I'm going to go ahead and hit review and launch. And go ahead and launch. I don't actually have this is a new account, so I'm just going to create a new key pair. I'm just going to call it my 2018 KP. I'm going to go ahead and download that, and now I'm going to go ahead and launch my instance. That can take a couple of minutes, but as soon as it's ready, what I'm going to do is go ahead and SSH into this EC2 instance. And then we'll pick it up there. So I'm just going to pause the video and wait for this to come up online. Okay, so I'm in my terminal window. I'm just going to quickly chmod, I think it was called my 2018, I think it was with a capital my 2018 key pair, and I'm going to chmod that to 400 so I'll be able to use it. Then I'm going to SSH to EC2-user and then then my public IP address, and then and then it was my 2018 key pair. That should hopefully log me in. Type in yes, and I'm going to elevate my privileges to root, so sudo su. I'm going to clear the screen. Okay, so let's just check that the AWS role is working and that I can list all my buckets. So AWS S3LS, I can see all my buckets in there. Let's clear the screen. Let's make a new bucket for this. So AWS S3 make bucket, and we'll call it S3, and we'll call it a Cloud Guru pre-signed, something like that. Hopefully that is available. And so that has now created the bucket. Next thing I'm going to do is I'm just going to make a little text file. So I'm going to call it, hello.txt. Oh, sorry. So I should say, I'm going to echo hello cloud gurus. And then I'm going to output that to hello.txt. And if we just type in ls, we can see it in there. Next thing I'm going to do is I'm going to copy that over to S3, so AWS S3, and then copy, and then it's just hello.txt to S3, and then it's a Cloud Guru pre-signed, and just hit enter. and that has now copied it up. If I want to view that, I just type in AWS3 ls, and then it's S3, and then A Cloud Guru pre-signed, and hit enter. And you can see that hello.txt is there. Let's just quickly jump back over to the console. So I'm back in the console, going to go over to S3. I'm going to go and find that S3 bucket. We're going to see if we can access the hello.txt file. So it's called A Cloud Guru pre-signed, which is here. And we can see the file in here. If I actually go and click on it and I click on this link, I'm going to get an access denied, and that's because by default the bucket is private and we haven't given anyone access to this object. So let's go back over to our terminal window and let's go ahead and clear the screen. So to do this, all we need to do is type in the command AWS S3, then pre-sign. That's literally it. And then S3, and then the bucket. So it was A Cloud Guru, and then it was called pre-sign. So pre-signed, and then it was hello.txt. Now I could hit enter here. If I do that, it's going to pre-sign the URL by default of 60 minutes, so 3,600 seconds. If you want to make that shorter or longer, all you need to do is do this, do expires, and then in, and then the value. So we could say 300, which would be 300 seconds. So it's the value in seconds. Go ahead and hit enter. That will generate your pre-signed URL. So you can see here it's still https acloudpresign.s3.amazon.aws.com/hello.txt. And then this is the pre-signed URL, and it's generating basically an access key ID, and then it says it expires, and this is a timestamp, and then we have our security token, and this security token is essentially like our secret access key ID, except it's only relevant to this one object, and that's how we'll be able to view it. So if you just copy it and paste that into your clipboard, so here I am in Chrome, if I just paste that in and hit enter, it should, hopefully, there we go, Hello Cloud Guru. So I didn't need to go in and, do any changes to the object ACLs or to the bucket policy or to IAM. I made this object public just by using the command line and generating a pre-signed URL. Okay, so what are my exam tips? Well, pre-signed URLs, you can access objects using pre-signed URLs. You don't need to go in and configure object ACLs or S3 bucket policies or IAM policies. You can just generate a pre-signed URL on an object. Typically, this is done using the SDK, but you can also do it using the CLI, as we've just seen, and they exist for a certain length of time in seconds. The default is an hour, but you can change this using the expires in followed by the number of seconds, so you can change this around. So that is it for this lecture, guys. Just bear that in mind going into the exam. Feel free to delete that EC2 instance. We won't be using it anymore. And if you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at S3 bucket policies and specifically how we can restrict IP ranges to our S3 buckets. So you can restrict access to your S3 addresses so that only particular IP addresses can access your S3 buckets. You might do this to an external IP address or an internal IP address range. For example, perhaps the bucket contains confidential financial information and you only want the finance team, who are on 10.0.12.x/24, to be able to access this information. And to do this, you use a bucket policy. So let's have a look at a bucket policy that would do this. So here we go. In here, we've got our bucket policy, we've got our statement, we've got our ID, and then the effect is allow. We're going to allow star. The action is, or allow wildcard. The action is to S3, so we're going to allow any action to S3. The resource is the ARN of our bucket. And then the condition is in here, and there's two conditions. You've got IP address, so we're going to allow access to this particular IP address. And when we have not IP address, we're going to block access to this particular IP address. So here we can put in an entire range. So we could do a /24, so 10.0.12.0. So anyone on the 10.0.12 IP address range will be able to access this S3 bucket. However, if you're on an external IP address, let's say it's 54.240.143.188/32, so this is an independent or an individual IPv4 public address. Maybe this is a hacker who's been trying to hack your site. You can then specifically go out and block them using the not the IP address. So this will come up in your exam. You will see this where basically you've given a scenario question and you need to either allow access to a particular IP address range or to block access using a particular IP address range. And all you do is you look at the condition and you use IP address to allow access and you use not IP address to deny access. So that is it for this lecture, everyone. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to continue just quickly looking at S3 and we're going to look at how we can use AWS config with S3. So this is a lab and you will need to log into the AWS console. Okay, so here I am in the AWS console. So we need to go to config. You'll find config under management tools. So here it is right here. If you go ahead and click on that, it will open up config. You can see here I still have some non-compliant rules left over from a few sections ago. In particular, I haven't been restricting SSH access. This is exactly what we want it to do. We want it to alert us where we're not being compliant. If we go over and click on rules, we can go ahead and add a rule. And in here, if we just filter the results by typing in S3, there's a couple of rules you need to be aware of for your Certified SysOps Administrator Associate exam. The first one being public S3 bucket public write prohibited. So this basically just checks that S3 buckets do not allow public write access. So you can't just go in, anyone can't just go in and write to that bucket. And then the other one you should be aware of is this, and this is quite important for production anyway. This basically checks that your S3 buckets do not allow public read access. So if your buckets are publicly available, AWS config will flag it up and it will alert you using this rule. So what are my exam tips? Well, just be aware of those following config rules. So you can have a config rule for S3 which has no public read access, and there's also a rule that has no public write access. Do remember that going into your exam. So that's it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at AWS Inspector versus AWS Trusted Advisor. And this is a favorite sort of game that Amazon like to play is they will talk about a service and you have to guess which one it is, and they always play these two off against each other because they do sound sort of similar. One's an inspector, sort of like Inspector Gadget I guess, and then the other one's a trusted advisor, someone that advises you about your account. So let's start with Inspector. So Amazon Inspector is an automated security assessment service that helps improve the security and compliance of applications deployed on AWS. It basically automatically assesses applications for vulnerabilities or deviations from best practice. After performing an assessment, it's going to produce a detailed list of security findings, and they're going to be prioritized by level of severity. And these findings can be reviewed directly or as part of a detailed assessment reports which are available via the AWS Inspector console or API. So we're going to go in and install this on an EC2 instance, and it's basically going to go in and tell us what's wrong with it. So how does it work? Well, the very first thing you do is you go in and you create an assessment target. You then go into your EC2 instance and install an agent on there. Then we're going to create an assessment template, and then we're going to perform an assessment run, and then we're going to review our findings against the rules. So let's have some fun. Let's log into the AWS console and get started. Okay, so I'm logged in the AWS. Okay, so I'm logged into the AWS console. The very first thing I need to do is go and provision an EC2 instance. We're going to need this in order to install Inspector on there. I'm going to leave everything as default. I'm not going to add a Bootstrap script to apply updates because we don't really want this thing to be updated. We want AWS Inspector to tell us that there might be some kind of security vulnerability. So just leave everything as default, hit next. Now with tags, let's leave tags off for now because you do need tags for Inspector to work. So I want to show you how it all fits together. So I'm just going to leave tags off for now. I'm going to put this into my default security group, so it's going to go into my web DMZ security group. I'm going to go hit ahead and go and review and launch. And I'm not actually sure if I have this key pair, so I'm just going to create a new key pair just to be safe, and I'm just going to call it my new key pair. and I'm going to go ahead and download it, and that's downloaded, and I'm going to go ahead and launch my instance. You can go in and view your instances. Don't worry too much about it just yet. Let's go over to services, and you'll see that Inspector is in security, identity, and compliance. And this will really help you in the exam because Inspector sits here, whereas Trusted Advisor is more of a management tool. So Trusted Advisor does have some security aspects to it, but it also will tell you how to save money. It will tell you a whole bunch of performance things, and we'll go into Trusted Advisor in a little bit. When you come into your exam, if it's a really security-related question, it's probably going to be Inspector over Trusted Advisor, but read the question carefully. So let's go into Inspector. We should just get a splash screen because I don't think I've ever used it in this region before. No, I haven't. So I'm going to go ahead and hit Get Started. Now, the very first thing we need to do is create a role. I have used it in another region, so there will already be a role that's been created for this, but I'll just create a new role. In here it says, click Allow to give Amazon Inspector read-only access to resources in your account. If you view the details, you'll be able to view the policy document, and in here it will say EC2 describe instances. And that will essentially, that's the only permission it has, so it'll be able to describe my EC2 instances. So just so this doesn't have an error, I'm going to call my role Inspector 2. If you haven't done this before, just use the defaults and go ahead and hit Allow. So there we go. My internet's running a little bit slowly. So we've done that. Now it says tag your EC2 instances, and the way it does this is using tags. So let's go ahead and click on this button here to tag our EC2 instance. So I'm in the Manage Tag section. You can go ahead and hit Manage Tag. I don't actually know. Let's go over to EC2 dashboard because I don't actually know my instance ID that I just spun up. So it's this one that's initializing, so it ends in F5C. Sorry about that. I'll just go back over to my tags. So F5C, so it's this one, and I'm going to go ahead and add a tag. So your tag, there's the key and then the value. So we'll say production web server, something like that, production web server, and then the value is yes. So everything that is in production would have the key production web server and then the value yes. If it wasn't in production, we'd have the value of no, something like that. So go ahead and add that tag to your EC2 instance. Now, if we go back over to Inspector, which is in my other tab, I've now added that tag. What I now need to do is go and install the AWS agent on my EC2 instances. So click on there, it will give you installation instructions. Probably the easiest way to do it at scale is using Systems Manager run command. So you go in and do it across an entire fleet. Because I've only got one instance, I can just click on this one here. And so essentially I need to SSH into my instance and run the wget command. And then I just need to run the sudo bash install command. And then that will be it. So let's go do that now. So I'm in my terminal window. Because I did download a new key pair, I just need to chmod it. So we just type in chmod 400, and then it was my new key pair.pem and hit enter. And now I'm ready to SSH. And if you've forgotten how to SSH into an EC2 instance, please check out section 1 of the course where we cover it in both Windows and a Mac. So Mac users, you just need to type SSH, EC2, then -user, and then @ and then we just need to get the public IP address. And so my public IP address is that, and then -i, and then the name of your key pair. So it was my new keypair.pem, hit enter. It will ask you if you want to connect, just type in yes. And then we want to elevate our privileges to root, so type in sudo su and then clear the screen. Now all I'm going to do is just cut and paste these commands in here. So I'm going to install. So we've gone in and downloaded it. And then what we need to do is just sudo bash install. Because I'm running at root level, I don't need the sudo, so I can just type in bash and then install. And then that will install it onto my EC2 instance. And there we go, it says complete. And it might take a little bit of time because it installs a whole bunch of different dependencies. And then you can't go in and check it, but I'm going to trust that it works. By the way, just coming back, and this is a security course, it does say optional, verify that Inspector agent installation script is not altered or corrupt. So that's where you're going to verify the signature of it. Click on that if you want to go through and verify. I obviously trust the Amazon documentation, but you could argue that you should always verify installation scripts before running them anyway. So I'm back in the Inspector window. I've installed my agent on my EC2 instance. I'm ready to go ahead and hit next. Now in here we've got to define an assessment target. So let's pretend that this is our production web servers. So we'll say production web servers. So this UI can be a bit clunky. I'm not sure why. It's a bit buggy. Sometimes you click in here and you'll be able to see all your new tags. Sometimes you won't see the tag at all. If you do forget your tag, just go back over to EC2 and have a look at what it is. Mine was called production web server, and then the value was going to be yes. And like I said, it's really frustrating. If you hit enter, it doesn't click on it. So you've got to actually click on it. I mean, so there we go. I'm going to hit next. And then this is our assessment template. Okay, so this is the really cool thing. So let's call it my production web server vulnerability check, something like that. And of course, I probably spelled vulnerability wrong, but there you go. I always find it very ironic that I've become a teacher, but I really struggle with spelling the word curriculum. So in here, we've got our rules packages. So what do you want to do? Do you want to do security best practices 1.0? Do you want runtime behavior analysis 1.0? Do you want common vulnerabilities and exposures 1.1? Or do you want the Center for Internet Security Operating System Security Configuration benchmarks? And that's really fascinating, actually. Basically, they have the Center for Internet Security have a whole bunch of hardened or requirements to make a hardened operating system, and this will basically check whether or not your operating system is hardened. I'm going to go for common vulnerabilities and exposure. I'm going to run this for 1 hour, or the duration is 1 hour, which is recommended. You can see here that says that assessment templates with longer durations can deliver fuller sets of findings. So it could even be that you want to go in and take one of your production web servers and just create an AMI of it, and then essentially go ahead and deploy it into another availability zone and maybe even another completely different subnet. And then you go in and run it over 24 hours, and then any issues that you see on that machine, you can assume will be on your web, in your web server farm. So everything is ready to go. Let's go ahead and hit next, and we'll go ahead and hit create. And it's creating everything that we need. And what we need to now do is we've created it. So we've got our assessment template here. And what we need to do is click in here and then just go ahead and hit run. And again, this is going to take an hour. So we've got a success, a run started, and you're going to have to wait an hour for now. Okay, we can see that it has completed a run. If we go over to assessment runs, we'll be able to see our run in here. And you can see that it has 0 findings, and we can go ahead and download our report. Now, I was a bit surprised that it had 0 findings because I haven't patched the operating system. I'm going to go ahead and download the full report, and I'm going to make it a PDF. So I'm going to go ahead and generate that now. If you are generating it for the first time, it can actually take a couple of minutes. It is a 669-page document, so do bear that in mind. We'll scroll down. We've got our executive summary, and it's basically saying that the rules packages was assessed, a total of 0 findings were created. And what rules packages? Well, common vulnerabilities and exposures. So if we scroll down into section 2, it will tell us what was tested. So it's these rules, so common vulnerabilities and exposures. What targets were tested against? It will tell you the number of instances it's actually targeted. So we have definitely tested it against an instance, and you've got the instance ID in here. In 3, there's a findings summary, but we don't, because there were no findings, there's nothing in there. And then in 4, we've got our finding details, but again, because there was no findings, there's nothing in here. 5 is pretty cool, though. It tells you what was tested. So if we have a look at this one, cross-domain vulnerability in the version 8 JavaScript engine in Google Chrome before blah, 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 blah. So you can scroll down and have a read of all these different rules that it's testing. What I'm going to go ahead and do now is I'm going to go and create a master template. Okay, so I'm back in the AWS console. If I go over to assessment templates, we're going to create a master template, and with the master template, what we're going to do is test all our rules, and we're going to do that over a 24-hour period. So in here, my rules packages, I can click on multiple rules packages, so I can add more and more and more. So right now I'm going to add all 4. So we're going to do security best practices, runtime behavior analysis, common vulnerabilities and exposures, Center for Internet Security Operating Systems Security Configuration benchmarks, etc. So I'm going to do this over a 24-hour period because I want to know that I'm going to get really good data out of this. I'm actually recording this on a Sunday night, so I don't want to set up an SNS topic because it will drive my wife crazy. I'm going to leave everything else as default, and then I'm going to go ahead and hit create and run. That will take 24 hours, so I will come back tomorrow afternoon. Okay, so that has now completed. I can click in here and download my reports. We've got 4 findings, which is interesting. So we click on findings. we'll be able to see the different findings. So we've got one from the SIS operational systems, we've got one from we've got two from runtime behavior analysis, and we've got one from security best practices. So if we go back over to our assessment runs, we can go in and download and view our report. It does take a little bit of time to download the report, so go ahead and hit generate. And then in here we'll be able to see our report, so we can scroll down and get an executive summary. For some reason it's only showing up 3 different rules packages in this report, but we do know that the Center for Internet Security did run because it came up in that other part I was just showing you. So I'm not actually sure why SIS isn't in here, but it isn't. But aside from that, we can go through and see here it says rules packages count is 3. So we've done common vulnerabilities and exposures, runtime behavior analysis, and security best practices. We don't have the Center for Internet Security in here. I have absolutely no idea why, but it has definitely run, because if we go back here and go to our findings, we can see the finding in here. So maybe this just doesn't generate a report. If anyone knows the answer to that, let me know. So it has run against this instance count. We can go through and do our findings summaries. So we've got a findings table, we've got insecure client protocols, we've got unused listening TCP ports, and we've got disable root login over SSH, which we should go in and fix. You can read the details in section 4, and then in section 5 you can go ahead and see everything else that has passed. Okay, so this is what Inspector is. So if you're getting into your exam and you're seeing a scenario-based question where you're installing an agent on your EC2 instance, or where you need to generate reports as to security vulnerabilities, then obviously you want Inspector. Now, we're going to move on to Trusted Advisor. Okay, so what is Trusted Advisor? Basically, it's an online resource to help you reduce costs, increase your performance, improve your security, and also improve your availability by optimizing your AWS environment. And essentially, it has 4 different things: cost optimization, performance, security, and fault tolerance. It has a whole bunch of core checks and then recommendations, and it's split into 2 different service levels. So you've got your basic Trusted Advisor, which mostly just advises you on security, and it does also advise you on some performance issues, or one performance issue, and the rest of it is all locked away, and you need to be a business or enterprise customer in order to unlock it. So let's go have a look at it in the console. Okay, so we've really gone through an Inspector in a lot of detail. Let's go ahead and look at one of our other services, Trusted Advisor. So Trusted Advisor advises you across 4 different things. It advises you across cost optimization, performance, security, and fault tolerance. And the actual level of which it advises you depends on your support plan. So if you've got the basic support plan, or no support plan, or developer support plan, you won't be able to access this. You need either business or enterprise to be able to access essentially all of the services within Trusted Advisor. But you do get a whole bunch of services for free, so it does check things on your security groups, IAM usage, multi-factor authentication on your root account, whether or not you're getting close to any service limits, whether or not you've got any EBS, public snapshots exposed, etc., etc. And so most of these are security. If you want to view them on a vertical basis, just click up here. Cost optimization is completely locked out, so basically you have to pay Amazon more money in order for them to tell you how to, save money. Performance is just around the service limits. Security, there's quite a few security points, so MFA on root account, IAM usage, etc., etc. And then in fault tolerance, if we click in here, again, you have to pay Amazon money in order to get it. So there are some basic services in here. I guess when you go into the exam, ask yourself, is this question asking me about cost optimization or performance or fault tolerance? If so, then you want your Trusted Advisor to come in and just, remember, something like an accountant. That's a Trusted Advisor. It has nothing to do with security. If it's a security question, what is it really asking? Is it asking you about installing an agent on your guest operating system and then, creating reports that map back to the Center for Internet Security, something like that? Well, of course, then that's going to be Inspector. But if it's just asking you to tell you whether or not you've got some security groups unlocked, or if you've got MFA on your root account or something like that, then that would be Trusted Advisor. So you really need to have a good understanding between the 2 different services going into the exam. Also remember that you need at least business or enterprise subscription in order to unlock all the Trusted Advisor's recommendations. Okay, so what are my exam tips? Well, if you should remember the difference between AWS Inspector and Trusted Advisor. With Inspector, what we do is we go in and we create an assessment target. We then went in and install agents on our EC2 instances. We then created an assessment template. So we did a vulnerability one, then a master one. We then performed our assessment runs. The default one is an hour, but you can run them for up to 24 hours. And we then review the findings against the rules, and it generates this really nice PDF report. The rules packages, there's 4 currently. So there's common vulnerabilities and exposure. There's the Center of Internet Security Operating Systems and Security Configuration Benchmarks. There's security best practices, and there's runtime behavior analysis. Then we have different severity levels for rules within Amazon Inspector. So we had high, medium, low, and informational. So what will Inspector do? Well, it will monitor the network, file systems, and process activities within the specified target. It will compare what it sees to security rules. It will report on security issues observed within the target during the run, and then it will report findings and advise remediation. What it won't do is relieve you of your responsibility under the shared responsibility model. It's still your responsibility to go in and patch those EC2 instances, and it won't perform miracles either. Moving on to Trusted Advisor, and this is where they like to trick you. You know, you're going to get a scenario question, and they're going to say, should you use Inspector or should you use Trusted Advisor? Well, if it has anything about installing agents on EC2 instances, then you should definitely be using Inspector. If it has anything around cost optimization, availability, or performance, then you should be using Trusted Advisor. Trusted Advisor also does security as well, though. So do remember that there's 4 things for Trusted Advisor: cost optimization, availability, performance, as well as security. So that is it for this lecture, guys. Hope you had lots of fun. If you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture we're going to look at AWS service limits. So this does come up in the Certified SysOps Administrator Associate exam an awful lot. So you might be wondering what a service limit is. Well, every AWS account has a service limit by default. A service limit is simply the number of services you are able to provision on a per account basis. For example, you could only provision so many EC2 instances, depending on the instance type and region, and then it will stop you from provisioning more. You then have to basically log a request to lift your service limits. So you can view your service limits by clicking on this link below. This link is in the resources section of the course, and it will lead you to a page that looks like this, and then you've got your service limits for all the different AWS services. So we've got Alexa for Business, for example. We've got API Gateway, Application Auto-Scaling, etc., etc. If we go down and see if we can find EC2, you can see it here, EC2. So EC2, your service limit, you get 5 elastic IP addresses for EC2 Classic, or 500 security groups, or 5,000 key pairs, or 500 placement groups, etc., etc. And when you go beyond this, you need to raise a request with Amazon in order to up your service limit. So if you want to know what your service limits are, AWS Trusted Advisor offers a service limits check, and it's in the performance category, and that will display your usage and limits for some aspects of the services. And so this is going to come up an awful lot in scenario-based questions. You'll be trying to do something, it's not working, you're trying to figure out why. What service should you use to test your service limits or to check your service limits? You must use Trusted Advisor. So that's typically where it's going to come up in your exam. So going into the exam, just remember that all AWS services have service limits. These are unique and on a per region basis, and you can always check your service limits by using the AWS Trusted Advisor service. So that is it for this lecture, everyone. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. This is the Shared Responsibility Model lecture, and this is one of the most fundamental concepts of security in AWS. You need to understand this model inside out if you want any chance in passing your exams. It's also really important to know for real life as well. So we'll make this a little bit fun. It can be a dry topic, but it is really, really important to understand this well. So what is the shared responsibility model? Well, while AWS manages security of the cloud, security in the cloud is the responsibility of the customer. So it's your responsibility to be secure in the cloud. Customers maintain control of what security they choose to implement to protect their own content, platform, applications, systems, and networks no differently than they would an on-site data center. And I like using the analogy of if you're renting a house, the security of the actual house itself is the landlord's responsibility. So they've got to, obviously put up fences. They've got to have, an alarm, put in the fire alarms, that sort of thing. But the actual security of the objects inside the house is your responsibility. If you leave your front door wide open and somebody comes in and robs you, that is not your landlord's, responsibility or fault. That's your own fault because you've left your front door wide open. So I like to think of it as that kind of analogy. So what is AWS's responsibilities and what are your responsibilities? So this can be very broad, and it can also depend on the service that we're talking about, as you'll soon see. So AWS's security responsibilities from a broad sense is on global infrastructure. So they're responsible for their data centers. They're also responsible for the hardware, so all the networking, all the SAN, storage arrays, all the physical servers, etc. They're also responsible for the software that they install on there, depending on the service. So the hypervisors, definitely they're responsible for. Some operating systems they'll be responsible for, things like RDS, for example. And they're obviously responsible for all the facilities inside the data center. And then they're also responsible for some managed services. So these are things like S3, things like DynamoDB, etc. And we'll come to how that breaks out in a little bit. What is the customer's responsibilities? Well, they're responsible for infrastructure as a service, so things like EC2, and we'll explore that in a little bit. They're responsible for including things like updates and security patches. So you're responsible to go in and patch your EC2 instance. You've got to always apply yum update or do the Windows updates when it first launches, and then apply all relevant security patches. And you're also responsible for the configuration of the AWS provided firewall. And by that, we're just talking about things like your VPC rules. So we're talking about things like security groups. We're talking about things like network ACLs, etc. So let's have a look at the shared responsibility model. So we've already covered security of the cloud in the previous lecture. In the next lecture, we're going to cover security in the cloud, and then we'll basically round up of what we've learned so far. So security of the cloud are things like compute, storage, database, networking, regions, availability zones, edge locations, etc. Essentially, it's where you don't get access to the underlying operating system. If you don't have access to the underlying operating system, then Amazon is responsible for patching that. In some cases, you don't even get access to the underlying applications. So things like DynamoDB, S3, these are abstracted services. You don't even have access to that. You're only then responsible for things like encryption, encryption at rest, encryption in transit, etc. And we'll explore that in a little bit. And then in terms of what the customer is responsible for, they're responsible for security in the cloud. So this might be things like client-side encryption and data integrity and authentication, things like server-side encryption, both from a file system or data point of view, network traffic protection. So this is, are you using HTTPS when you're uploading your, files to Amazon? Things like operating systems, network, and firewall configuration. So you're responsible for your EC2 instances, you're responsible for your security groups, you're responsible for your network ACLs, platforms, applications, identity, and access management. Again, things you're definitely responsible for IAM if you go out and provision a user who has full admin access, and then for some reason you, issue an access key ID and secret access key, and that code goes up onto GitHub. Well, there are bots out there that scan GitHub just looking for access key IDs and secret access keys, and as soon as they find them, they go in and try and provision EC2 instances to mine Bitcoin. So, you're responsible for securing things like that, and obviously you're always going to be responsible for your own customer data. It's not Amazon's responsibility. So the model changes for the different service types. So we have 3 different service types. We have infrastructure, we have container, and we have abstracted. And it's really, really important important that you understand the three different types and the different examples of different services for how the model changes, because you're going to be tested on this a lot. So let's start with infrastructure services. So this category includes compute services such as EC2, EBS, autoscaling, and VPC. With these services, you can architect and build a cloud infrastructure using technologies similar and largely compatible with on-premise solutions. You control the operating systems, and you configure and operate any identity management system that provides access to the user layer of the virtualization stack. So that makes total sense, right? EC2, EBS, things like autoscaling, things like VPC, things like your security groups within your VPC, your network ACLs. In terms of EC2, in fact, let's have a look at the next slide. So if we think about EC2, you're going to be responsible for things like your Amazon machine images, your operating systems, your applications, your data in transit, and your data at rest. You're responsible for your data stores. You're responsible for the credentials, the private key and the public key. Those credentials are your responsibility. If you put your private key somewhere up on the internet and somebody finds it, well, you've just given away the keys to the kingdom, so don't do that. And then policies and configurations. So from an infrastructure point of view, you're basically responsible from the operating system level up. Moving on to container services. In this, you've got a service that's running on an EC2 instance or some form of other infrastructure instance, but you don't manage the operating system. That's the responsibility of Amazon, and Amazon call this container services. So you'll be responsible for setting up and managing network controls such as firewall rules, and for managing platform level identity and access management separately from IAM. So examples of container services include things like RDS, Elastic MapReduce, and Elastic Beanstalk. And RDS is the one that I think of all the time because, you've got a database there that you can install and access, but you don't manage the underlying operating system. In that respect, Amazon are responsible for both the patching of the operating system as well as the patching of the security patching of your RDS instance as well. So security patching of MySQL or SQL Server or Oracle or whatever. We then have abstracted services, and this includes high-level storage, databases, messaging services, and things such as like S3 or Glacier or DynamoDB or SQS or SES. And these services basically abstract the platform or management layer on which you can build and operate your cloud applications. You can still access endpoints of these abstracted services using the APIs, but AWS manages the underlying service components or the operating systems on which they reside. So you don't have to worry about patching the OS or patching the actual application that runs S3. Amazon are going to take care of all that for you. In terms of S3, what you do need to worry about is your bucket policies, for example. That is absolutely your responsibility. If you set a bucket policy that allows people to read and write the entire contents of your bucket, that's pretty silly. So that is your responsibility. So what are my exam tips? Well, in the Certified SysOps Administrator Associate exam, you will see the shared responsibility model pop up at least a couple of times in your exam. It's just important to understand who is responsible for what. That's what you're going to be tested on. So you're responsible for things like EC2 OS patching, as well as antivirus. You're responsible for things like security groups, VPC configuration, etc., your network ACLs, whatever you have control over. You're not responsible for things like RDS, the actual operating system in which RDS runs on. You're not responsible for patching that OS. You're not responsible for patching RDS database applications. So if SQL or MySQL needs an update, Amazon are responsible for that because you don't have that level of access to RDS. And then things that you wouldn't necessarily think about, things like PHP. Normally with PHP on EC2, you'd be completely responsible for that. But if you're using PHP with Elastic Beanstalk, well, Amazon are then managing that. So PHP updates with Elastic Beanstalk, you're not responsible for. So just have a good understanding of the shared responsibility model, what you are responsible for and what you aren't responsible for, and you're going to pick up a couple of marks. Okay, hello Cloud Gurus and welcome to this lecture. So almost at the end of this section of the course. This lecture is just called Other Security Aspects. Basically, I could have had 4 or 5 separate lectures, but I thought it would just be easier to compartmentalize them all into one, so you only have to watch one lecture. So I actually went and did the SysOps Administrator Associate exam again yesterday, as soon as it came out of beta, and so I wrote a whole ton of notes, and there were a few little gaps in the course which I'm trying to plug now. So this is a very important lecture on things that you should definitely need to know before going and doing your exam. So let's start with security groups. We are going to cover security groups in the VPC section of the course. I just want you to be aware, because we are in the security section, you need to have a firm understanding of security groups and how they work. So security groups are stateful, and all that means is that if you open up a port on your inbound port list, automatically that's going to allow outbound traffic on that port. So let's say we open up port 3306, which is for MySQL, or let's say we open up port 1433 on a security group. That's known as ingress traffic, so it's going to come into our security group. By default, when we open those ports up, egress traffic is also automatically allowed. So you might get a scenario question where you've got some web servers and they're trying to communicate to RDS. Let's say they're trying to do it over port 1433. So this is the SQL Server port. And for some reason you can't connect to the database. Well, the way to troubleshoot that is to check the security group that the database is behind, and just make sure that you've allowed port 1433 through on ingress. So make sure you've opened up port 1433 on that security group for RDS. Another thing you should bear in mind about security groups is you should be able to read security group rules. So you'll get various different scenario questions where you'll be given a security group and what the different inbound rules are. So here's an example. Maybe we've got a Bastion host here, which is sitting in a public subnet. Anyone can SSH into this Bastion host, and then using this Bastion host, they can then SSH into some EC2 instances that are in a private subnet. Now you might be reading your logs, and you could see that this particular instance has 5 people SSHing into it at any given time. You might wonder, well, why is that when I've only allowed the Bastion host? If you go through and read your security groups, you'll be able to see potentially that you've opened up this particular security group. So let's say it's this one here to 0.0.0.0. So you're saying basically any instance that's in this, in this subnet is connecting in to this instance through SSH. So long as it's behind this security group, any instance can go and connect in to this instance here. The way to solve that is to lock this down. So instead of saying 0.0.0.0, you may want to lock it down to a specific private IP address. So it could be this IP address, so it's a /32, which could be the private IP address of just one instance inside this subnet, which is behind this security group. So just be able to read your security group rules and obviously know your port numbers, especially very popular ports like port 80, ports like SSH, which is on port 22, ports like 1433, which is SQL Server, and 3306, which is MySQL. Moving on, let's look at a different scenario. So maybe you've got a huge estate. Maybe you work at a company like Verizon or Accenture or any of the major players, maybe CloudReach or Rackspace or you name it, LogicWorks. And let's say you manage literally thousands to hundreds of thousands to potentially even millions of AWS environments. And you've got one account in there, and basically someone keeps going in and provisioning EC2 instances. And you're like, who the hell is doing this? We've got so many people in our organization. How do I know who's provisioning these EC2 instances? Well, if you've got CloudTrail turned on, CloudTrail is going to log any API call that's made to S3. So that's great. You've got all this information stored in S3. But let's say this is a production account for Capital One, for example, and that you've got literally, let's say, 1,000 developers who have access to this production account. How do you know which developer is doing it? You could go through and read the CloudTrail logs manually, but that's going to take an awful lot of time. Alternatively, what you can actually do is use Athena. So you can use Athena to query S3 and pull out the data as to who is provisioning these EC2 instances. So that is a great way of, basically figuring out who's provisioning, assets within your AWS account. Just make sure you've got CloudTrail turned on, and if you've got an awful lot of data, use Athena to query your S3 bucket where CloudTrail is storing the logs. Moving on, you will see a lot of mention of AWS Artifact, and in my opinion, a lot of them are red herrings. So just understand what Artifact actually is. Artifact provides on-demand downloads of AWS security and compliance documents, such as AWS ISO certifications, PCI, and Service Organization Control, or SOC reports. And you could submit security and compliance documents, also known as audit artifacts, to your auditors or your regulators to demonstrate the security and compliance of AWS infrastructure and services that you use. So Artifact is simply a way of getting documents. It's a way of getting things like your ISO certifications, PCI certifications, Service Organization Control reports, etc. From a single source, and you'll be able to use those documents to submit to your auditors or regulators just to demonstrate you know what you're doing and that AWS is compliant with their particular regulations. That's all Artifact is. And you'll probably see Artifact as a red herring, like I said. Basically, just to understand what Artifact is and what it does. It's not a service that provisions EC2 instances. It's not a service that does does data archival or anything like that. It is literally a service to get security and compliance documents from. Moving on, you should have a good understanding of Cloud HSM versus KMS. With Cloud HSM, it's a dedicated physical device that's dedicated to you, so your tenancy is single. KMS is shared. In terms of scale and HA, you now have HA services from both AWS for Cloud HSM and KMS. It used to be that Cloud HSM was just single points of failure, but they have changed that now. Who controls the key? Cloud HSM gives you a lot more control. So you have control of the key. With KMS, it's a combination of you and AWS. In terms of support, basically Cloud HSM has broad support across AWS as well as KMS. And then this is really, really important, symmetry. So down to if you want symmetric and asymmetric keys, so if you want to manage both symmetric and asymmetric keys, use Cloud HSM. KMS is only used for symmetric keys only. So if you want to generate, for example, let's say you're using EC2 and you want to generate your public key and your private key. Public key and private key, because it's two keys, it's asymmetric, okay? So there's two keys. And in order to generate public keys and private keys, and to store and manage them, you can use Cloud HSM. You cannot use KMS to generate and store public keys and private keys, okay? So KMS is symmetric only, whereas Cloud HSM is symmetric and asymmetric as well. And also on compliance, if you ever see compliance needed for FIPS 140-2, then you're always going to need Cloud HSM. To be honest, that would be more a security specialty question, but just bear that in mind. Whereas for KMS, because it is multi-tenanted, you're not going to get that FIPS 140-2 compliance. And Cloud HSM is slightly more expensive than KMS. Cloud HSM used to be super expensive, used to be like $5,000 a month, but Amazon have now done utility billing, so it's basically a couple of dollars per day or per hour, I think. So you can actually get a really, really good experience, hands-on experience with Cloud HSM without paying $5,000 a month. And I would recommend, if you do enjoy the security part of this course, going on and doing the security specialty. In there we cover Cloud HSM and KMS in an awful lot of detail. You'll be provisioning your own Cloud HSM devices in your own custom VPCs. You'll be using KMS. We'll be using Cloud HSM to generate public keys and private keys, which you'll then use to log into our EC2 instances. So it is really, really cool hands-on stuff. And finally, moving on to encryption. Let's say you've got an environment. It consists of like EC2, EFS, RDS, maybe some DynamoDB, and some S3. And let's say there's been a big data breach and suddenly someone's gone in and they've pulled all your data from there, and your management is just screaming saying, right, we need to encrypt everything. Everything at rest must be encrypted. You need to understand which services you can encrypt instantly and which services you can still encrypt, but you're going to need to do a migration. So S3, you can go in and encrypt anything in S3 instantly using server-side encryption. You don't need to migrate to a new bucket or anything like that. You can literally just go in and turn on encryption. Other services such as EBS, such as EFS, such as RDS, and such as DynamoDB, you need to actually create a new environment that's encrypted and then do a data migration from your existing environment to your new environment. And I'm guessing from reading the documentation that's probably going to change in 2019 for DynamoDB, because they kind of hint that they might enable encryption at rest for non-encrypted environments. But right now, you definitely need to do a migration for things like DynamoDB, RDS, EFS, and EBS, whereas S3, you have instant encryption. So that is it. You're almost at the end of this section of the course. In the next section, we're just going to go on to the exam tips, and then you're ready to move on. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at AWS CloudTrail. It's going to be a mixture of theory as well as a hands-on lab. So we covered CloudTrail a little bit off in the last section, but we didn't really do a deep dive. So this is a deep dive on the service. So what is it? It's a web service that records AWS API calls for your account and delivers log files to you. So what does this actually mean? Well, let's have a look at an example. So over here we've got the Amazon Cloud, and that's could not just be a VPC, but that could be things like S3. This could be any kind of service like Lex or Poly or whatever. And then we interfacing with the cloud, we've got our control plane. So this is our control plane, and basically our control plane consists of a whole bunch of public APIs. And when our user goes and interacts with the AWS platform, they do this either using the console, which is what we're most familiar with, or by doing an API call. So what do I mean by an API call? Well, here we go. We just type in AWS S3. So I've got the command line tools stored in here. We're going to do make bucket, and then I'm going to call it hello Cloud Gurus, and then just a whole bunch of random numbers, and that will go ahead and provision a bucket. So it's just making a simple API call to the control plane, and that has now provisioned a bucket for me in S3. So like I said, using the API or the console, we can actually provision things like DynamoDB databases or S3 buckets or EC2 instances, etc. So basically CloudTrail is going to log all this. So it's going to log that there's been a creation to my DynamoDB database. It's going to log that I've just created an S3 bucket. It's going to log that I've created an EC2 instance. What it won't log is things like RDP or SSH. So if I RDP or SSH into that EC2 instance and start installing things on it, CloudTrail is not going to log that. It's going to log API calls only, and that's really critical to understand going into your exam. So remember that it's only going to log the API calls. So what does CloudTrail enable us to do? Well, we get after the fact incident investigation. So if something goes on inside our AWS account, we can go back and look at the CloudTrail logs and see what exactly happened. And we get near real-time intrusion detection. So we can see as soon as somebody provisions a resource, that's going to be recorded in CloudTrail, and we'll be able to see that as well. It also gives us industry and regulatory compliance, because as soon as you turn CloudTrail on, suddenly you have an audit trail. So CloudTrail logs API call details for supported services, and you can get a list of the supported services down here. If you just go to docs.aws.amazon.com/CloudTrail/latest/user guide/CloudTrail supported services. And here it is, CloudTrail supported services. And if you scroll down, there's an awful lot of stuff that's supported by CloudTrail. In fact, it's actually more interesting to click on the unsupported services because these basically tell you what is not supported. So right now, Batch isn't supported, Glue isn't supported, Greengrass isn't supported, Shield isn't supported, etc., etc. So what is logged? Well, metadata around API calls, the identity of the API caller, so who's making the API call, the time the API call was made, the source IP address of the API caller, the actual request itself, so what is it that they're trying to do? They're trying to provision an S3 bucket or an EC2 instance, and then the response elements returned by the service. So maybe S3 doesn't allow that particular user to create a bucket, so the response was a failed, or maybe it was a HTTP 200 success, something like that. So these are all the different things that CloudTrail is logged. So where is this all logged? Well, it's all sent to an S3 bucket, and you manage the retention yourself in S3, because when you send files to S3, by default, they're going to stay there forever. So you're going to need to set up policies, such as lifecycle management policies, to start either deleting this data or archiving it off to Glacier. It's entirely up to you. It depends on your organization. The actual logs themselves are delivered every 5 minutes to S3. And when you actually make an API call to any service, it won't necessarily be delivered to CloudTrail for up to 15 minutes. So this is why we say near real time. It can take about 15 minutes for the CloudTrail service to essentially log that item, and then every 5 minutes those logs are sent over to S3. You can set up SNS notifications, so you can set up a notification so that if somebody creates a S3 bucket, it notifies you automatically, or if somebody creates a new EC2 instance, it notifies you automatically. And you can aggregate your logs across multiple different regions, and you can also aggregate your logs across multiple accounts. And in some ways that's a really good security best practice, because if you have a separate AWS account with a separate root account, that essentially means that you can send all of the logs from your production account to a completely separate AWS account in a completely separate S3 bucket that only you can access. So that way, if somebody comes into your production account and they're a system administrator on your production account and they go through and start destroying everything, they can't then go into that separate AWS account and then go in and destroy the logs. So you'll have evidence of them doing it, and that is a good example of non-repudiation. So how do we do this? How do we set it up? Well, it is actually enabled by default. This is relatively new. It's only happened in August 2017, but it is now enabled by default for 7 days. So every AWS account will have CloudTrail turned on for the 7 days, and it will be sent to an S3 bucket, and you'll be able to go in and have a look, as to your logs, within CloudTrail. If you want it to go for longer, you need to go in and provision it. So let's go do this now. Okay, so I've logged into the AWS console. If we go down to services, you'll be able to see CloudTrail here. It's actually under management tools, not under security. Go ahead and click on that. You'll be able to see your recent events. So here's a whole bunch of recent events. You can see where I started using AWS Config Manager and in the last section. So that's my most recent event. So this is all being logged for the last 7 days, and you can go in and view it by clicking the event history. If we go back down here, it says these are the most recent events recorded by CloudTrail. To view all events for the last 7 days, go to event history. Now, right now, this is saving it to an S3 bucket. That S3 bucket isn't actually visible to me in S3. So what I need to do, if I want to, have audit trail for longer than 7 days, what I need to do is go ahead and create a new CloudTrail. So why don't we go and do that? I'm going to call this trail name and it has to be at least 3 characters, CloudTrail, very unique name. Apply trail to all regions. Now you could say no, and you could only apply it to specific regions, but that would be pretty stupid. You may as well apply it to all regions because you want to know what people are doing inside your AWS environment. We choose our different event types. So by default it is all, but you could have read only or write only. And to explain this, basically you could have a CloudTrail for just read only events. So if you're running an API operation such as describe EC2, that would be a read-only event, and you could send that to a read-only bucket. A write-only event could be something like terminate my EC2 instance. That's a write event, and that would send it to an S3 bucket that is a write-only S3 bucket. I'm just going to do all as a default. In here we've got our data events. So this we can actually record down to S3 object levels. So we could actually see people putting data up into S3, as well as people going in and changing it. If you do that, though, additional charges are going to apply. I'm not going to. I'm just going to leave it as default. Storage location. So in here we have to go in and create a S3 bucket. I'm going to call it my CloudTrail bucket, a Cloud Guru. Hopefully no one's taken that name. and I'm going to, in here you can actually click on advanced and you can have log file prefixes. You can say whether or not you want to encrypt your logs. In here by default it says enable log file validation, which we'll go through in a couple of slides. And in here we've got send SNS notification for every log delivery file. So every time it sends a file to S3 every 5 minutes or so, that would also trigger an SNS notification. To me that would be a nightmare, so I'm going to say no. I'm going to leave this enable log file validation though, and we're not going to encrypt our log files by default. So what we then do is we just go down here and hit create, and this should create our CloudTrail, and it can take a little bit of all this. It's provisioned or immediately. Yeah, that's actually really good. So the next thing I'm going to do is I'm just going to go back over to services, and I'm going to go down into CloudFormation, and I'm going to use CloudFormation to provision myself an entire new WordPress environment. So if I go down to create a new stack, we can use a sample template. Feel free to click on the WordPress blog and go ahead and hit next. In here we've got our stack name, so we'll just call it my WordPress blog. You can see I've already done this before. I'm going to use everything as default, so I'm going to take my DB table name actually, copy that into my clipboard, and I'm going to make that my password. I'm going to make that my user. I'm going to use a T2 micro because I'm cheap. My key to this is the actual private key or key pair to log into your WordPress environment. If you wanted to do that, we'll go ahead and do that. And in here we've got our SSH location, so we're going to open up this security group to the whole world. Go ahead and hit next. You've got some optional tags in here. We've got some optional identity access management roles. I'm just going to leave everything else as default and hit next, and we're going to go in and create it. And I really don't care whether or not this works, the WordPress blog works or not. What I do care about is what is going to be logged in CloudTrail. Now, like I said, it can take 15 minutes for this to be sent to CloudTrail, and then it can take another 5 minutes for these logs to be sent to our S3 bucket. So I'm going to pause this video for about 20 minutes. Okay, so it's been roughly 20 minutes. If I click in on CloudTrail, I should hopefully be able to see, yeah, here we go. Here's a whole bunch of CloudFormation, results. So it has logged all this, and hopefully it has sent it over to S3. So let's go into services and go down to S3. And in S3 we should see our bucket. Okay, so here I am in S3, and I'm going to go ahead and click on my CloudTrail bucket, A Cloud Guru. This is the one I created earlier. Right now all I see is AWS logs. I then click on my account number, and then I click on CloudTrail, and there will be a new folder here under this subdirectory after we've had our CloudTrail turned on for just over an hour, and we'll see that in a bit. But that's essentially going to contain our digest files, and our digest files basically is a way of checking that nobody's gone in and changed our CloudTrail files. So if you click into CloudTrail, you'll see all the different regions. I spun up my my CloudFormation template in Northern Virginia, so that was in US East 1. If I click in here, we've got the dates, so 2017, it's November, it's 7th, and in here you can see all the different CloudTrail logs. You can go ahead and download these and check the logs and then see what people have been doing. So that is CloudTrail logs in a nutshell. I'm just going to go back to this subdirectory. Actually, I think it's just under my account number. Like I said, it will take an hour. There you go. It literally just provisioned. I shocked myself. So here is our digest folders, and in here this is the way that we can check whether or not the CloudTrail logs have been altered. Okay, so your digest files are essentially a way of validating whether or not your logs are actually valid, whether or not somebody, they're real logs, or if somebody has gone in and changed them. And the way it works is you've got to enable log file integrity validation, which we did when we were creating our CloudTrail. And essentially it creates a hash for every log file that's delivered. So every hour, CloudTrail creates and delivers a file that references the log files for the last hour and contains a hash of each. Now the hash is generated using public keys and private keys. Amazon themselves have the private key, so you'll never get access to that, but you can use a public key. And essentially what you can do is go in and just see whether or not the hash is correct and whether or not that file has been changed. If you scroll all the way down to the bottom, you can see validating CloudTrail log files integrity using the command line. You can click in there and it will give you the syntax as to how to validate your logs. Again, it's a little bit beyond the scope of this course, but you should just be aware of the digest file and its ability to check that your logs haven't been changed. So again, validating CloudTrail log file integrity, you can validate whether or not the log file's been modified or even deleted. And the way you do that, CloudTrail log file integrity validation comes with SHA-256 hashing, and for added, security, you've got SHA-256 with RSA for digital signing. So the log files are always delivered with a digest file, provided you turn it on, of course. And digest files can be used to validate the integrity of the log file. So that's it for this lecture, guys. In the next lecture, we're going to look at how we can secure our log files and why we should secure our log files. And it's going to be a mixture of hands-on labs as well as theory. So if you've got the time, join me in the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we're going to look at how we can protect our CloudTrail logs. This lecture is a mixture of theory as well as practicality. So CloudTrail logs contain metadata, not application data. So why should you consider securing them? Well, essentially, CloudTrail logs can contain personally identifiable data, such as usernames and even team memberships. Also, detailed configuration information, such as your DynamoDB table and key names, could be stored in your CloudTrail logs. And so this information may prove valuable to an attacker and is considered best practice to go ahead and secure CloudTrail logs. So how do you go about doing this? Well, the very first thing we want to do is obviously stop unauthorized access to our log files, and we can create identity access management policies and S3 bucket policies to restrict access to the S3 bucket containing the log files. We can use things like server-side encryption S3 or server-side encryption using KMS to encrypt our log data. So we talked about identity access management in the last slide, and this, just to further extend on this, how can we restrict log access to only employees with this security responsibility? I mean, we don't really want our HR people or our marketing people to be able to go through our CloudTrail logs, right? So how do we do this? Well, you place the employees who have a security role into an IAM group, and then you attach the policies that enable access to the logs. So let's go into identity access management and create two different groups of CloudTrail users. Okay, so I'm in the AWS console, and I click on services, and I want to go down to identity access management and go into here. And with IAM at the moment, I've already got a group. This is a group, administrator group, which is basically where I put my administrators. Now, an administrator is going to have full access to CloudTrail, and you probably, you always want least privilege. So let's go ahead and create two new groups. We'll call this my CloudTrail admin, and go ahead and hit enter. And then the policy type, if we just type in CloudTrail in here, we can see our two different policies. So we've got our AWS CloudTrail full access and our AWS CloudTrail read-only access. And in using CloudTrail, you should grant the people who are going to be doing the actual, managing your AWS environment, they should have full access to CloudTrail because they're the ones that are going to go up and, set it up, etc. But do be aware that they could then turn it off. So make sure it's people you trust. When you come in and have an auditor come in, you probably want to grant them AWS CloudTrail read-only access. So they can go in and see, read the data, but they can't make any changes to it. I won't go through and create the groups and attach these policies because you probably already know how to do it, but just be aware of these two default policies for CloudTrail. Okay, so how can we be notified that a log file has been created and then validate that it's not been modified? Well, you can configure SNS notifications and a log file validation on the trail. So we didn't configure SNS notifications, but we did configure log file validation on our trail in the last lecture. And you saw we went in and had a brief look at where the digest files were saved. And then you can basically develop a solution that when triggered by SNS will validate the logs using the provided digest file. And you might not want to do that, that doesn't make a lot of sense to do that immediately, because if somebody actually goes in and changes it a couple of hours after the log, you wouldn't necessarily capture that change, but you might set up some kind of Lambda function, that basically goes in and compares the digest files of yesterday or last week's or something like that with the actual logs, and then basically does that automatically, and it will trigger an SNS notification to you if something has changed, so you know that someone's been going in and altering your log files, which would be very, very suspicious. The cool thing about digest files as well is because Amazon have the private key, you can't go in and manipulate the hash. You couldn't go in and change the log files and then go in and suddenly create a new hash so that the digest files match back to the log files. You can't do that because Amazon have the private key, and I could only imagine the security around the actual protection of those private keys. It must be massive background checks, etc., for Amazon employees to go through before who actually manage those private keys. So how can we prevent log files from being deleted? Well, you can restrict delete access with identity access management and bucket policies. You could also configure S3 multi-factor authentication delete, and you can validate that logs have not been deleted using log file validation as well. How can we ensure that logs are retained for X number of years and in accordance with our compliance standards? Well, by default, log files are going to be kept indefinitely. You can use S3 object lifecycle management to remove the files after the requirement period of time, your required period of time, or you could move the files to AWS Glacier or more cost-effective long-term storage. Why don't we take a quick look at how to do that in the console, and then we'll go on to my exam tips. Okay, so I'm here in the AWS console. If I click on my CloudTrail bucket, a Cloud Guru, I can go in here. We've got a whole bunch of different tabs up here. If we just go over to management, we can go ahead and create a lifecycle rule. You can click in here. We could call this delete after 30 days. Maybe you only need to create your logs or you only need to store your logs for 30 days. In terms of the transitions, you want to do this for current versions or previous versions. I'm just going to say for current versions, go ahead and hit next. This is configure your expiration. So again, whether or not you want to expire the objects, I'm going to say current versions, and we're going to do this after 30 days from the object's creation. And then we obviously want to just clean up incomplete multi-part upload. So it's up to you. You might just leave that as default. Go ahead and hit next and go ahead and save it. And that will create a lifecycle policy which will now expire my objects after 30 days. So I'm only going to keep 30 days worth of logs. Another thing we might want to look at is if we just go over to properties, we go on to default encryption. There's no default encryption turned on for my bucket, but if I actually go into the files themselves, if I click on AWS logs, click on here, click inside CloudTrail, go in and find, I think it was Northern Virginia, so it's going to be US East 1, which is down here. Go to 2017, 11, and 7. It's only a couple of weeks for reInvent, so I'm really looking forward to it. And then in here, if I actually click on the objects, we can see there's server-side encryption AES-256. So this is being, encrypted by default. And we can also use KMS as well, but I'm happy to just use AES-256. So let's go over to the exam tips because we have learnt an awful lot. By the way, if you want to go ahead and turn off CloudTrail, you can. I personally wouldn't. I'd go ahead and create this rule so that you're only logging 30 days worth of information, but it's up to you. Okay, so my exam tips. So what have we learnt so far about CloudTrail? Well, we learnt that our user, when they make API calls or use the console, that's going to hit a public API, and this is essentially the control plane. This is what we use to control the Amazon cloud. They can go in and provision things like DynamoDB tables, S3 buckets, EC2 instances, etc. And essentially CloudTrail is going to log all this. What CloudTrail is not going to log are things like RDP or SSH sessions into your EC2 instances. So it's basically anything that's appearing at the public API level. What else did we learn? Well, what is actually logged? And basically it's metadata around the API calls. So we log a few things. We log the identity of the API caller. We log the time of the API call. We log the source IP address of the API caller. We log the request parameters. What is it they're trying to do? Are they trying to provision an EC2 instance? And then we also log the response element. So were they able to actually go in and provision that EC2 instance? So moving on, once we have captured this log information, where is it saved? Well, it's sent to an S3 bucket. You manage the retention in S3. Remember, S3 is designed to store your files forever. You might not want to store your log files forever because they can get quite, can take up a lot of space, especially considering if your AWS environment is filled with literally thousands of EC2 instances. In terms of timing, it's delivered every 5 minutes, only if there's an active log. So essentially, like if nothing happened in my AWS account, then nothing would be sent to S3. Let's say nothing happened for an hour, nothing would be sent to S3 within that hour. Let's say someone then goes in and provisions an S3 bucket. It can take up to 15 minutes for CloudTrail to recognize that, but as soon as it does, it will then deliver that log file to my S3 bucket within 5 minutes. Notifications are available, so you can configure SNS notifications. So you could say, oh, look, somebody has created an S3 bucket, please notify me on my phone. And you can also aggregate your logs across regions, which we saw. We turned it on for all regions, and you can also aggregate it across accounts as well. So you can have an S3 bucket in another account, and you can send all your CloudTrail logs there if you want. In terms of validating the log file's integrity, how do you know that somebody hasn't altered the logs or deleted the logs? What you can do is you can basically turn this on so that you get digest files. Remember that it takes an hour to create a digest file, but it's done on the hour, every hour, and then they can be used to validate the integrity of the log file themselves. And you can't fake a digest file because you do not have the private key. Only AWS have the private key. Some more exam tips: you should protect your CloudTrail logs because they contain everything you're doing within your AWS account, and it may contain personally identifiable information such as usernames, email addresses, etc. You should allow your security people with admin access to CloudTrail, your auditors with only read-only access to CloudTrail using IAM. You should restrict access to S3 using bucket policies, and you should use multi-factor authentication delete on your objects. You should use lifecycle rules to move data to Glacier or to just delete it entirely like we just set up. And then you should also check the integrity of your log files using your digest files. So that is it for CloudTrail, guys. I hope you enjoyed the lectures. And if you have any questions, please let me know. If not, feel free to move on to the next lecture. Okay, hello Cloud Gurus and welcome to this lecture. So congratulations, you're at the Security and Compliance Summary. You're getting towards the end of the course. In the next section of the course, we're going to learn all about networking and DNS. It's extremely hands-on, the next section of the course, so it's also lots of fun, and the best way to learn AWS is by being hands-on. Hopefully you've had fun in this section of the course too. If you do have an interest in security, it is a very highly paid field. One of the most in-demand qualifications right now is the AWS Certified Security Specialty, because as you can imagine from an employer's point of view, who does not want employees who are certified in security on AWS? We do have a Certified Security Specialty course available on the CloudGuru platform. I do recommend you go check it out. It is extremely hands-on as well. So let's start with compliance. We learned all about the different compliance frameworks that AWS is compliant with. There's way too many to list, so I've just listed the ones that I think are the three most important. Do check out aws.amazon.com/compliance. So we covered off PCI DSS, ISO 27001, and we talked about HIPAA, which is the health compliance for the United States government. And there's a whole bunch of other things like FedRAMP, you name it, AWS is compliant with it. So you can learn all about it by going to aws.amazon.com/compliance. Also, if you do want to be able to memorize things like the PCI DSS, steps, get these books. Get the Memory Book by Tony Buzan. Tony Buzan was the creator of Mind Maps. If you've ever used Mind Maps before, he was the guy who invented it. Darren Brown is a UK entertainer, and he is super famous in the UK, and he's written a book he's famous for his memory as well. And both books actually teach the same things. The way you remember things is by creating these things called memory palaces, and it's like basically remembering a story. Human beings are very good at remembering stories, much better at doing that than remembering lists and facts and that sort of thing. And so all you do is you take what you want to remember and you put it into a story, and then you'll be able to remember the PCI DSS steps, or you'll be able to remember the Amazon leadership principles, all 14 of them. Or like I did, I got tonsillitis once and I decided to learn all 45 presidents of the United States. It's just fun to do, so I would recommend getting those books. Anyway, enough about books, let's move on to what we learnt about. So DDoS, let's start with DDoS. It's definitely worth a few points in the exam. I would read this white paper, so we're going to have a link in the resources section, so do check that out. Remember the technologies that you can use to mitigate a DDoS attack, so CloudFront, Route 53, and Elastic Load Balancers, all of those are protected by AWS Shield. Shield will come onto Shield, but it comes in standard as well as advanced. You can also use web application firewalls to protect against layer 7 attacks. These are like flood attacks, or like what we looked at, the slow Loris attacks. And then we can also use auto-scaling, and we can use these for both WAFs and web servers, as well as CloudWatch to alert us for when we're being DDoS. So do check out that AWS DDoS white paper when you get the time. Just remember that AWS Shield is turned on by default. It's free. It's $3,000 a month if you want the advanced option. Advanced gives you an incident response team and in-depth reporting, and you won't have to pay for any additional costs that you may incur if you're a victim of an attack. And for the enterprises, $3,000 a month is really nothing, especially if you are a big company and you're very likely to be targeted by a DDoS attack. Remember that you can buy products through the AWS marketplace. Definitely you can buy security products, so you can purchase from third-party vendors on the marketplace. You can purchase things like firewalls, hardened OSs, WAFs, antivirus, security monitoring, etc. In terms of what you pay, some of them are free, some of them are hourly, some of them monthly, some of them are annual, and some of them are just bring your own licenses. And the Center for Information Security also has OS hardened images on there, so you can have a Linux hardened image or a Windows hardened image. You don't have to go and do any of the hardening yourself. You can just use the Center for Internet Security, and that is hardened to an international standard. And shameless plug, A Cloud Guru subscriptions are also available on the AWS marketplace. I'm very pleased with that, and that means that you don't have to go necessarily through a procurement process. If you want to sign up your teams inside your company to A Cloud Guru and you enjoy our training, it will actually come off your AWS bill. Moving on to identity access management, you can create custom policies using the visual editor or by creating your own JSON. You can now attach roles to EC2 instances at any time using the command line or the AWS console, and once attached, the role takes effect immediately. Any policy change, and the policies are always attached to roles, will also take effect immediately. Moving on to multi-factor authentication, you can enable MFA using the command line and also using the console. MFA can be enabled on both the root account as well as user accounts, and you can enforce the use of MFA with the CLI by using the security token service. And how to do that is in this link, which we'll also have in the resources section. And you can report on who's using MFA on a per user basis using the credential reports inside Identity Access Management. We created that CSV file. We had a quick look at who was using MFA and who was not. Moving on to security token services. So remember how it works just from a high level. So you got your employees here, they're logging in the morning. This could be a web application, just say it's any web application. So they log in, they enter in their username and password, that you use to sign into Windows, for example. Let's say that they want to then log into AWS. So what happens is they log into this system. System will contact an identity broker that you develop yourself. The identity broker then communicates with Active Directory, for example, or Facebook or LinkedIn or whatever, whoever your OpenID provider is. That will then say whether or not those credentials, your username and password, are correct. If it is, it will give you a token. The identity broker will then go to the AWS security token service. It will get an STS token as well, and then it will pass that STS token to your AWS services that you're using. The AWS services will take that token, bring it over to IAM and say, okay, IAM, is this a valid token? And if it is, IAM will then basically go ahead and grant them access to those resources. So that's how security token services work from a very high level. Logging in AWS, just remember the different services that do logging. So CloudTrail, AWS Config, CloudWatch Logs, as well as VPC Flow Logs, and just have a firm understanding of the difference between CloudWatch, CloudTrail, and Config. In terms of VPC flow logs, we're going to cover that in the next section of the course. So CloudWatch monitors performance. CloudTrail monitors API calls on the AWS platform, so who's created that S3 bucket or who's created that EC2 instance. And then Config records the state of your AWS environment and can notify you of changes. So it's basically like a CCTV camera. It can tell you what rules your security groups were 3.5 weeks ago, for example. So just to have a firm understanding of the difference between the three going into the exam.
Also remember at a high level what an AWS WAF is. So it's a web application firewall, it's layer 7 aware, and it allows you to monitor HTTP and HTTPS requests that are forwarded to either CloudFront or an application load balancer or to API gateway. AWS WAF also allows you to control access to your content. It does not integrate with classic or network load balancers, so bear that in mind going into your exam.
Moving on to AWS hypervisors. So you always want to choose HVM over ParaVirtual wherever possible. ParaVirtual is isolated by layers. So you've got your guest OS layer sits on layer 1 and your application layer sits on layer 3. Only AWS administrators have access to the hypervisors. AWS staff do not have access to EC2. That is your responsibility as a customer. And all storage, memory and RAM memory is scrubbed before it is delivered to you. So remember that going into your exam. Dedicated instances versus dedicated hosts. A lot of people kind of get these a bit confused, and I can see why. But just remember that both dedicated instances and dedicated hosts have dedicated hardware. So they always have dedicated hardware. The difference is dedicated instances are charged by the instance and dedicated hosts are charged by the host. And if you have specific regulatory requirements or licensing conditions, make sure you choose dedicated hosts. Dedicated instances may share the same hardware as other AWS instances, but only from the same account that are not dedicated. And then also remember that dedicated host gives you much better visibility to do things like sockets, to monitor things like sockets, cores, and host ID, etc. Moving on to Systems Manager run command. So commands can be applied to a group of systems based on AWS instance tags or by selecting manually. So you could go in and just say, okay, I want all my web servers that are running PHP. Maybe you have is running PHP tag or something. And then you can go and do an update to PHP. And you don't have to SSH into each individual one. You can run it across fleets of EC2 instances. SSM agent needs to be installed on all your managed instances. The commands and parameters are defined in a Systems Manager document, and commands can be issued using the AWS console, the CLI, AWS tools for Windows PowerShell, as well as the Systems Manager API, as well as the Amazon SDKs. And you can use this service with your on-premise systems as well as EC2 instances, which is seriously cool. So you can manage both your AWS environment and on-prem all using the same single pane of glass. Moving on to parameter store. So confidential information such as passwords, database, connection strings, license codes, etc. can be stored in SSM parameter store, and you can store values as plain text, or you can encrypt the data. And of course, you probably want to encrypt the data. You can then reference these values by using their names, and you can use this service with EC2, CloudFormation, Lambda, EC2 run command, etc. Moving on to pre-signed URLs with S3, so you can access objects using pre-signed URLs. Typically this is done via the SDK, but you can also pre-sign your URLs using the command line as we did in our lab. And they exist for a certain length of time in seconds, so you always set a time to live, and the default is 1 hour. And you can change this by using the expires in flag followed by the number of seconds. So you use pre-signed URLs where you want to share files that are within S3, but you don't want to make them public. You just want to share them with individual users by sending them a unique URL that only they can use.
Also remember at a high level what an AWS WAF is. So it's a web application firewall, it's layer 7 aware, and it allows you to monitor HTTP and HTTPS requests that are forwarded to either CloudFront or an application load balancer or to API gateway. AWS WAF also allows you to control access to your content. It does not integrate with classic or network load balancers, so bear that in mind going into your exam.
We then move on to AWS config rules with S3. Just be aware that if you want to identify which S3 buckets are publicly readable or even publicly writable immediately, you can use AWS config rules. It will alert you. You can then go in and change the permissions on the buckets. So just be aware of the following config rules: no public read access and then no public write access. So you set those rules and it will show you any buckets that are publicly readable or publicly writable. Moving on to Inspector, it's an exam favorite, certainly in security specialty, but also in SysOps Administrator Associate. So how does it work? Well, basically you go in and you create an assessment target. You then install agents on EC2 instances. Now, because you are installing agents, remember you can only do this where you have operating system level access to EC2. You can't do this using RDS. You can't use Inspector with RDS because you do not have operating system level access to RDS. You then go ahead and create an assessment template. You then perform the assessment run, and then you review your findings against your rules. Your rules come in a whole bunch of different packages. So we've got the common vulnerabilities and exposures, or CVEs as it's called. We've got the Center for Internet Security Operating System Security Configuration benchmarks. So these are your hardened OSs. We've got your security best practices, and then we've got runtime behavior analytics. And the severity levels for rules in Amazon Inspector go from high, medium, low, and informational. So what Inspector will do is monitor the network, file system, and process activity within the specified target. It's going to compare what it sees to security rules. It's then going to run reports on security issues observed within the target during the run, and then it will report findings and advised remediation. What it won't do is relieve you of your responsibility under the shared responsibility model, and it's not going to perform miracles. It's not going to go in and fix those issues for you. You have to go in and fix them yourself. They like to mix up Inspector with Trusted Advisor. Remember that Trusted Advisor really is looking for things like cost optimization, availability, performance, as well as security. So Inspector you're using to evaluate security vulnerabilities. Trusted Advisor could tell you that could tell you that port 22 is open on your security groups, but it could also tell you that you're running your environment not in a cost optimized fashion. So Advisor is there to advise across a whole bunch of areas, not just security, but cost optimization, availability, and performance, whereas Amazon Inspector is for vulnerability scans and security scans only. Moving on, make sure you have a strong understanding of the shared responsibility model. So you're going to be responsible for things like EC2 OS patching, antivirus, security groups, etc. Anything that you can control the security settings in within AWS. You're not responsible for things like RDS OS updates, so making sure that the operating system which RDS runs on is updated. Even RDS database updates, and things like PHP updates when you're using things like Elastic Beanstalk. If you install PHP on your own EC2 instance, then absolutely you're responsible for that. But if Amazon's managing PHP for you, which it does in Elastic Beanstalk, then Amazon are responsible for the Elastic Beanstalk updates.
So remember going into your exam that AWS services have service limits, so like the number of EC2 instances that you can provision for a new account, a whole bunch of different service limits depending on the service. These are always unique on a per region basis, and you can always check your service limits by using AWS Trusted Advisor. So you might get a whole bunch of different scenario questions saying, hey, this isn't working, EC2 is not being provisioned, what's going on? Well, go into Trusted Advisor and check your AWS service limits.
Moving on to security groups. Security groups are stateful, so do bear that in mind. Here we've got a typical scenario where we've got a web server, it's trying to talk to a database server, and for some reason it can't do a database connection. The very first thing you should always do is check that the ingress rule is opened to popular database ports, so 3306 for MySQL, and then 1433 for SQL Server. Moving on, another popular question is behind when you've got security groups. Let's say you've got an instance in a private subnet and you've got a Bastion host and it's a /32 that can only connect in. So only this Bastion host can connect into this instance. But then you notice that a whole bunch of other instances are connecting into it. Check the security group. If other instances are connecting in, there's going to be a rule allowing it, and it might just be that it's o.o.o.o/o that's open to this security group. So bear that in mind as well. You just need to be able to read security group rules going into your exams, and we will cover security groups in a lot more detail in the VPC section of the course. Who keeps provisioning stuff? So someone is provisioning EC2 instances in your environment. You work for a huge company. The way to diagnose who's doing this is make sure you have CloudTrail turned on. CloudTrail is going to log this to S3. Now you may have literally thousands or hundreds of thousands of users within your AWS production account, and it may have hundreds of thousands of lines of logs inside S3. You don't want to read that all on your own, so you can use things like Athena to query that data from S3. AWS Artifact, just understand what it is at a high level. It just provides on-demand downloads of AWS security compliance documents such as ISO certifications, PCI, and SOC or SOC reports. And then you can use these documents to submit to your auditors or regulators to demonstrate the security and compliance of the AWS infrastructure that you use. That's all that Artifact is. You go to Artifact to get documentation. Artifact is a huge, in my opinion, red herring in the exam. You'll get Artifact, you'll see it a lot as an answer. And for all these magical services, Artifact, all it does is give you documentation on your AWS infrastructure. So bear that in mind as well. Cloud HSM versus KMS. Well, the first thing to know is that Cloud HSM does both types of keys, so symmetric and asymmetric, whereas KMS only does symmetric keys. And then if you see anything that's talking about FIPS 140-2 compliance, that's always going to be Cloud HSM. KMS doesn't do that. KMS is multi-tenanted. Cloud HSM is a dedicated physical appliance to you that you pay for by the hour. And we do a lot of deep dives of Cloud HSM in the Certified Security Specialty course. Honestly, one of the hottest qualifications in tech right now is in security, especially security in the cloud. And it's also lots of fun. So go check out the Certified Security Specialty course once you've passed your SysOps Administrator Associate exam. And then finally, very last slide for this lecture. So instant encryption. Let's say you move into a new job and your workplace has just been hacked and they're like, holy crap, we haven't been encrypting anything. Let's just encrypt everything at rest. You need to understand what services you can encrypt at rest immediately and what services you need to do a migration with. So S3, you can go into your buckets and just start turning on encryption. You can turn it on for individual objects or at a bucket level. Whereas things like DynamoDB, things like RDS, EFS, EBS, etc., you can definitely encrypt them, but you need to encrypt a new environment first, and then you need to migrate the data over to the newly encrypted environment.
And then finally, just CloudTrail event logs. It's sent to an S3 bucket. You manage the retention in S3. It's delivered every 5 active minutes with up to 15 minutes delay. You can enable notifications, so things like SNS notifications, and your logs can be aggregated across regions as well as aggregated across accounts. Also remember, going into your exam, validating CloudTrail log file integrity. So you can definitely do this. Was the log file modified or deleted? And CloudTrail log file integrity validation comes with SHA-256 hashing. You can also have SHA-256 with RSA for digital signing. Your log files are delivered with a digest file. So always look for the term digest file when you get these scenario questions. That's a way of validating your CloudTrail log files. So digest files can be used to validate the integrity of the log file, and that will come up honestly 3 or 4 times in the exam.
So that is it for this section of the course, guys. Hopefully you've enjoyed security. Like I said, if you once you've done SysOps Administrator Associate, I highly recommend getting the security specialty. It is one of the most valuable qualifications in technology right now. So definitely check it out. If you enjoyed this section of the course, check out that course once you've passed your exam. So that is it from me. If you have any questions, please let me know. If not, go have a break and we'll move on to the next section. Thank you.